So, wir sind live und du kannst loslegen.
So, good morning everyone. Today we talk about content synchronization between TYPO3s on a multi-stage environment. Let me start with a short question. Who of you does use workspaces in a production environment? 1, 2, 3, 4. Yeah, some of you. Are you happy with it? So, let me introduce myself for a moment. I studied computer science in Leipzig until 2014. It was around 2010 I joined PHP and the open source community, and I started my first experience with different custom management systems. At the end of my computer science study, I wrote my master thesis about how to support educational environments, mainly, with open source and custom management. The main idea was there are many low budget projects, so how can we help them with produce their needs with open source so they don't have to pay for everything around it. And yes, in 2014 I joined Net Research and I start my experience with TYPO3 until today. Yeah, in 2006 we had a customer, we still have it, but in 2006 there was the request of this customer. They have a multi-stage environment. There's a stage system, the editors do their stuff there, they produce content, they build their pages and stuff like this. And they have a production environment. This is just a front end where the users come and visit everything. And yeah, until the days before, when the editors do their stuff on the stage environment, they have to sync all the files between stage and production. They have to do a full dump of the SQL between both, but they don't want this anymore. They wanted a way for their editors to do this stuff by their own. So yes, to bring this stuff from the stage system to the live system, we have to do the database changes from stage to live. We have to bring all the files from stage to live. They wanted to do it at any time, at night, at weekend. They don't want us to do. They don't want us to do it for them. Not every editor should be able to do it. Only the chief editor or the chief of a specific part of the site. Sometimes we have to do update deployments on stage and live, and if the deployment on stage is already done, so they can check, they can use their new extensions, new plugins and stuff like this, but they just test it and it's not yet ready on live. It would cause problems if they can already do the sync between both. So the admins, maybe we or the admins on the customer sites, should have a way to lock and unlock the sync. So the editors who don't know at the moment maybe about the deployment isn't done yet, don't have to care about if I'm allowed to do the sync now or not. So the admins can do it. Yeah. Another request was the sync between stage and live should be incremental or fully. So maybe there's a reason they want to sync every content, every files, every stuff they have from the stage system to the live system. And sometimes this requirement isn't. Maybe they just want to sync a page, a part of a page, a new page tree, something like that. They always want to choose where they can sync. Between the stage and the live system, there's another test system where they can some editors can check stuff, where they can play around with plugins and stuff like that. And sometimes they want to have their contents over there. And yes, so the timeline of the content synchronization and the NRSync extension behind it. In 2006, there was the initial commit. In 2019, other clients came with similar requests. So we remove any brands for the former customer. We recreated the extension and did the first big part to make it public one day. So yes, the second public presentation is today. The first one was, I guess, 2 years ago on the TYPO3 camp Mitteldeutschland. And yes, yeah, this is a short pic to explain what they have a stage system. Every editor can do their stuff there, creating pages, creating plugins. Yes, what an editor usually do. And then they want it on a test system, on a production system, or wherever. We can imagine to bring this content on this way on the development system. Yes. Tobias. So, yes, thank you. Let's have a short view in the backend module. Not every, it's based on the page module, so the editors can only see these pages they usually can see, so they can only sync these pages they usually see. There's another restriction on not every editor is allowed at all to sync stuff. I always talked about that admins can log pages because there is a deployment or any stuff is going on this page. So we shouldn't sync at that moment. And yes, they can choose between a full sync of every content they have. For example, they can choose the root page, but they can choose the root of a page tree, or maybe just a page with all the content in it. Or they can do an incremental sync. This is a little bit just the content we didn't sync since the last time. So every new content that were created since the last sync. Yeah, while the sync is going on, it first checks, okay, we have here content. The content has a new timestamp than the last sync. So it's important for our sync. We have content, the timestamp is older than the last sync. So we already synced it, so we don't need it for this sync. Yeah, still at the moment, the admins has to protect the systems and unlock it. Yeah, and in general, the editors just collect all the pages they wanted for the sync, add it to the sync, and just press a button to sync them later. In general, the extension at the moment offers 10 different syncs per default. For example, a sync of our backend users, a sync of the main records, a sync for the scheduler, but also a sync for content, pages, and the usually front-end content stacks. It offers a sync to integrate own stuff, and you have own plugin, own extensions with custom tables. You can easily integrate it. So it will sync the stuff you added to your customer's website too. Yeah. The sync process in a more technical way. We choose all the tables depending on the sync the editor took. We collect the TCR, so we know about which fields, what do we need to sync. We will prepare the queries. So, for example, if an editor deleted stuff or put it to hidden, and we don't want this stuff anymore on the live system, so we don't want to have it hidden or deleted on the live system. We just throw it away and prepare delete statements for the queries. We collect all the files that are needed for the page and the plugins we want to sync. Yeah, we write the dump files, so that are the files we needed for the database, we prepare a file list. So we have all files we need on the target system, and we prepare a statement which page caches are included. So the target system know which page caches should be cleared. And we updated the sync stats so we know in a further sync in the future which elements we already synced at the moment, so we don't need to sync it in the next incremental sync. Yeah, here's a short overview on what has happened. The stage system, the system where the editors did their stuff, but the DB dumps and the file list on a given storage, it's configured before, and on the target systems, the test system, development system, production system, whatever is your target system at the moment, has a scheduler task that came from the extension, and the scheduler task will check, is there new stuff I should collect, and then it collects there. Yeah. Yes? Can we have the second micro?
It's at the front.
On which systems do the sync services live? Do they live on the source system or the target system or the local system of the person doing the sync?
The sync service is on the origin system. And
Okay,
they put the files somewhere where they are needed, and the scheduler task on the target system know where the places is and collect the file there. The files there. The file list is collected via rsync, and yeah, the dump files are collected and then just put in the target database. Yeah. So we offer 3 hooks in general, and pre-process hook. That's, yeah, you can call it before the sync starts. So maybe you want to create some order tables that aren't part of this thing. Maybe you want. I'm not sure. There are many opportunities for it. Then a post-process sync that's happened after the sync starts. The extension uses itself, uses this hook itself to collect all the caches and the sites that are relevant for clearing caches. Another use case would be a mail. So important editors get a mail here. This thing is done. The new stuff is live. Please check it. Please do whatever you want with it. And we have a third hook. It's to add it's to the menu, so you can add your own stuff, your own tables, whatever you want to sync. So I was much faster than expected. Thanks for your attention. Any questions? Yeah. Well,
front-end user data or something else?
In general, it should be possible to sync in both directions because both TYPO3s has the extension, both TYPO3s has the opportunity to do it, but we never did it. Yes. Most parts of it are already working with 10, and we are on the way to bring it to 11.
What will happen if there are any merge conflicts? So, for example, the same record is changed. If you have a bidirectional sync, do we try to avoid bidirectional sync because of these reasons? or will things implode? What will happen?
Does something like this ever happened? No. Oh, you should.
Yeah, we once tried to implement it bidirectional using UUIDs, but it was quite a challenge. So we use it from the stage system to the production system. So the production system is more or less a slave of the stage system, which excludes this topic totally.
So, any further questions? Then, thanks for your attention.
Und wir sind live.
Yeah, welcome to my presentation on Cypress and TYPO3, or Cypress meets TYPO3. I'm going to talk about, of course, Cypress and how you can use it with TYPO3 for fun and for profit. And I'm going to present a way that I developed for a big project of mine on how to use Cypress to actually run useful tests for this project, but also for certain extensions within the project. And that's, I think, some novel approach that I just wanted to show you. And I also want to spread some love for Cypress because I think it's an awesome tool. Let's get started. What is Cypress? Cypress, as they themselves claim, can test anything that runs in a browser. And that, I think, makes it very suitable or very well suited for our purposes as web developers. And the good thing about Cypress compared to other approaches is that it already includes everything that you need for testing. If you've ever written any JavaScript tests in a browser, then or also not in a browser, unit tests for JavaScript, you might have had to choose an assertion library, some test runner, and other things. And Cypress has all that bundled. So you just install Cypress, and you're good to go. It takes, if you know what you're doing, it takes like 30 seconds, 1 minute to get it running. Then some time for the usual downloading half the internet. And then you can start Cypress. So all in all, depending on your connection and the speed of your computer, it's like 5 minutes setup probably. And we'll later on see how that works. So if you've been in my talk yesterday, you've already seen this pyramid, or also from other talks maybe, or other material. This is the basic, or this is the different types of tests that you can implement, or should also implement. I would, in each project, strive to have all kinds of tests for the different aspects of the project. But the part that we are talking about today is the acceptance part. So the upper, smaller part of the pyramid. We're not so much going to focus on the lower parts. It's just the functional tests that also come into play at one point, but we'll get to that later on. First, why I'm qualified to talk a bit about Cypress, where I'm using it. The project, also something that I already talked about yesterday. Roughly 4 years, we've got almost 16,000 commits by now. There's 50 custom extensions with 125,000 lines of code. And we don't have 100% test coverage for these 125,000 lines, but we aim to at least get all the functionality in there covered. And how did we get to try Cypress? Our test situation in early 2022 was like this. We had roughly 500 unit tests, roughly 400 functional tests, and around 80 acceptance tests. And the JavaScript part we're not going to talk about. Even though Cypress is a JavaScript test tool, these JavaScript tests are not what I mean when I'm talking about Cypress tests. This is more JavaScript unit tests like Vue.js component tests, or some, I don't know. I've not written these tests, so I can't tell you anything about them. So let's just ignore them for now. And the Cypress tests that we write are more in this category, acceptance tests. So the total number of tests was 1,000, and those two numbers, unit tests and functional tests, were fastly growing, kind of. But the acceptance test was stuck for like 1 year because we had several problems with them. And these tests were all implemented with Codeception. And a part of these problems was probably Codeception. A part of that was probably also our project setup. But we were not satisfied with Codeception, so I started looking for alternatives. And our problems with Codeception were to some degree due to its architecture, because our front end is driven by JavaScript. So we can't use, who's ever worked with Codeception? Okay, Codeception basically is a PHP testing tool, PHP acceptance testing tool, and it has two ways of executing these tests. One is that it can run a browser or drive a browser with the so-called WebDriver, which is pretty slow. There's Selenium involved. If you've ever worked with Selenium in some context, you know that it's brittle and sometimes breaks for no reason. But there's also another driver, I think Phantom driver or Phantom.js driver, that just renders your site and then does string comparisons. But it doesn't run any JavaScript. There is no DOM in there, as far as I know at least. I never looked into that because the documentation says it doesn't run with JavaScript, and that was just, we tried it and it didn't work, and yeah, so we just used WebDriver, and that also only worked half of the time. Okay, probably not half of the time, but we had random test failures far too often. It's also pretty slow because there's a lot of network traffic involved to run or to get a command from the PHP process of codeception into the browser, because it has to control the WebDriver, that has to control Selenium, blah, blah, blah. That is pretty slow. I already mentioned it. We had some tests that were notoriously flaky. That might also be a problem with how we wrote the tests, because I talked to some people using codeception over the last days, and they told me that there are ways to get around this, but we couldn't fix those tests. Probably also because of a lack of research and knowledge. But there's also another or two other problems. The first problem is that at least our tests had no reset after a write. So tests that changed stuff, and because our site is heavily driven by user input, we always, or in most tests, change data in our database. So that means you can run the test once because it checks, is there something in there, then adds something, and then checks, is the thing that was added actually there? And because that can only be done once, you need to reset the database and then run the test again. And I said yesterday we can reset the database or reset our system with 2 commands, and it's like 5 minutes. But still, if you have to do that each time you want to run the test, testing or debugging the test becomes really, really cumbersome. I know that there are ways around this, but because we wanted to really acceptance test our application and not try to capture or not try to do manual tests, basically, that was not really an option. So we wanted to also test our system setup with this. And the last part, and that's actually the thing that bugged me most, is that it's pretty hard to debug these tests because they run in the terminal. You can see what codeception does in the terminal, but that doesn't directly correlate to what you currently see in the browser, and you also can't jump back. And by the way I'm saying this, you probably already guessed that Cypress is the solution to all of this, because Cypress actually gives you ways to jump back in the test execution and see the state of your application in different stages of your test. And we're now half a year roughly into using Cypress, and that's our current situation. So the other test numbers have also grown. We're still not going to talk about JavaScript tests, but we added roughly 50 Cypress-based tests by now, and also more than 100 tests in the other 2 categories. And if you remember the pyramid, normally this number should be a lot lower than these 2. But because we're lacking some testing in the front end, I think that's okay. And it also, in my opinion, proves that Cypress is, in our case, a great tool to test things. So much for how or how we in our big project use Cypress. But what is Cypress actually? What does it look like? How does it work? I've got 2 screenshots, and then I can also show a short demo. So that's basically the user interface of Cypress. So you install it as an NPM dependency or yarn dependency or whatever, and then just open this graphical tool with a simple command. And it basically shows you all the different test suites that you have. And once you click, and you can also run this, so this is not actually a dedicated front-end tool of a dedicated user interface anymore. It's running in the target browser. So that's a shift from Cypress 9 to Cypress 10. We've used Cypress 9 until recently, and I just started using Cypress 10 a few weeks ago. So this is the most recent version of Cypress, at least the day before yesterday. Probably they already released a new version, I don't know. And this is actually running, or this is actually the target browser that your test will run in. So once I click this event detail or event registration, for example, they will, the view will change to this, and then then the screen basically becomes divided. You've got the different tests that are to be run or are currently running, and you've got the actual user interface that is rendered by what your test, by the actions your test performs. Yeah, and you also have some metrics, and so I'm not going to talk about the Cypress cloud integration today because I've used it for a short time, but you easily hit the limits where you need to pay for it, and that's not my decision. So I currently don't pay for Cypress, for the cloud integration, because we also don't need the cloud integration. We don't need the flaky test detection that they have. We solved the parallelization. That's also something that they give you if you throw money at them. We solved that differently already for our codeception tests, and we use the same setup for our Cypress tests as well, because it has proven to work well. And we also have a reporting inside our GitLab, so we don't need that as well. If you want to see anything of this, I can also show that. I just didn't put it into the presentation, but I guess we will have quite some time for questions later on. So if you want to know anything, or if there's anything unclear, you can also just interrupt me. Sorry, I didn't mention that in the beginning. Yeah, any questions until now? Okay, because otherwise I would quickly demo a simple Cypress setup. Okay, I need to somehow arrange this microphone now. Test, works, great. Okay, so I have prepared something somewhere. Yeah. So this is basically, or this is the most basic tree that lets you run Cypress. There's just a package JSON, which is pretty short. I think there's only one dependency in there. Yeah, no, two dependencies actually, because I like TypeScript. And Cypress is the only real dependency of this demo. There's a config file that Cypress automatically generates for you. And there's also the Cypress folder, which contains three folders in this case. The E2E is where our tests are. We're going to see that in a second. Fixtures is, for example, if you have a file with users that you use for logging in, or some other shared data between tests. For example, we have some PDF files that we use in tests that are uploaded, that are also placed in this folder. And support is for configuring Cypress and adding functionality to Cypress. We'll also see that later on because we need that in some aspects in our solution. Okay, now I'm just gonna run Cypress. And Cypress basically has two modes. The one is the graphical user interface that you've seen on the slides. And the other one is a CLI mode that basically runs in your CI pipeline, for example. But I'm now gonna go for the graphical tool. And this is the tool that opens when you when you open Cypress. Cypress Run would just execute the tests in a browser. By default, that's an Electron, but you can also switch to Chrome or other browsers by just giving a command line flag. So I also didn't mention that there's also the possibility to component test or do component testing with Cypress. We're not really using that. We've got one simple proof of concept test for that, but we didn't start that until now because we've got some problem or some, not really problems, but challenges because our components heavily rely on data that they retrieve from our API. And we need to generate API fixtures, and we don't have any way to reliably do this, because as soon as you generate fixtures, you always need to make sure the fixtures match the actual API return data. So I want to have a way to generate these fixtures automatically from actual API responses. So I can just regenerate them on one click, because I'm a huge fan of automation if you didn't get that by now. So each time we change the API, we can just regenerate the API mock data or fixtures and have the proof that our components can work with our actual API data, and not some data that someone wrote at some point in time, perhaps even without knowing what the API actually looks like. And I know there is stuff like what's it called, Swagger or OpenAPI. We don't have that. I'm sad. Okay, but let's not talk about component testing anymore. Let's look at E2E testing. So I can now select a browser, and as you can see, I've got 4 choices here. You can, I think, also integrate Edge if you're running on Windows. And you can also run that in Docker containers. There's pre-configured Docker containers provided by Cypress, by the Cypress project, that include, for example, Chrome and Firefox. And there's also an Edge container. However that works on a Linux machine, I don't want to know. I need to look into that at some point. But yeah, until now we're running our tests in Chrome, I think. So I'll just stick to Chrome for now. It's now opening the browser on the wrong screen. Yeah. And as you can see, there is one in this folder Cypress E2E. There's one test CI TS. We'll have a look at that later on. I'm just going to run this now so you can see how Cypress works. So we're now visiting the Developer Days 22 website, and that was lightning fast. I should have introduced some weights in there. So yeah, we basically see all the different steps that are taken during the test. So we first visit the Developer Days website. Usually you don't specify the full URL because you can specify a base URL in your configuration. So your tests don't depend on running on your local machine or on some cloud machine, because our tests usually run with the full stack. Like we fire up a full stack with Docker Compose, with a traffic proxy and an Apache for HTTPS termination, because I'm afraid of putting traffic directly to the internet. Yeah, don't ask why. And then we basically perform our tests. You also see all the different AJAX requests that are performed in between. But this is actually one part of our tests. We'll also see that in the test code in a minute. And you can also see that the element that this matches becomes highlighted. So it's easy to debug the test. And there is an assertion behind this or connected to this, because I expect the schedule item to be visible in the menu. And then I click it as the next action. And then there is a page load event, and the page is already loaded, and then there's loads of AJAX requests for whatever reason. And then I just check that I got to the right URL. You can also do that differently by just checking if the URL behind the A tag or the href attribute of the schedule item matches the location, but I just wanted to show you that you can also go to a different page. Yeah, and then we could assert, for example, that there is an item Thursday or a headline Thursday and it has the right date and blah, blah, blah. Maybe we'll get to that later on. Any questions so far? Okay, if there are any, just interrupt me and wait for the guy with the microphone before talking. That's also important because then the people in the stream can also hear it. Okay, let's look at the next test. That's basically similar to this. We visit the schedule. I'm sorry for the people in the back who can't read the bottom of the screen. Yeah, so we basically visit the schedule page and then try to find an A tag that has the text or contains the text Cypress meets TYPO3. So we're basically looking if my talk is actually still listed on the page. And the next test, that's the last one that I implemented. This is just demo stuff, so don't expect too much of it. The last thing actually tests that this talk is listed as advanced. So how do we implement that in code? I need to find the correct window. Yeah, there's the demo. And the funny game, where is the presentation mode? Appearance, I think, enter presentation mode. And there goes my, oh, really? There goes my project view. Okay. Yeah, there's loads of things in there that don't matter. So this is basically our Cypress test. If you've ever written any JavaScript-based tests, you might know this structure. There's a describe or context element around it that basically allows you to mark where you are or what you are testing. And this is listed in the white print here. And then the single tests that are wrapped within it are, yeah, if they are successful, listed with a green check mark. And you can also see the test body here. And that directly correlates. And yeah, this is a leftover from my first experiments. Because I disabled requests to some external sites, the cookie banner doesn't appear anymore. That's also a nice trick that to limit or to speed up your tests, you can disallow Cypress to perform certain requests to certain domains, for example, Google Analytics, or in this case, I think it's HubSpot or something, and that prevents the cookie banner from appearing. And at first I thought it doesn't work until my tests started failing because the accept button was not available anymore, or wasn't found anymore. Yeah, and then it's pretty simple. The three most simple operations that you will need for your first Cypress tests are visit, which changes the URL or goes to a certain page, then contains. There's also, if you know the element that you want by its CLI, by its XPath expression, for example, you can also use get. That just can't test for any text inside the element. So this would, for example, be good to check if the menu is actually there. Yeah. Yeah. So far, so good. I think that's actually pretty understandable just from reading. Yeah. There's a question? We need the microphone? Whoever has it? Oh.
Where? Thank you. In the line where it contains be visible,
yes.
on the top, yeah, should be visible. That would not work in the mobile view, isn't it? Because the menu item is not visible.
That's actually true. Yes.
Okay.
Yeah, that would not work in a. We can try that. I just need to. Yeah. Now you're asking me stuff that I've not tested beforehand. Let's just
That
try
was my intention, yes.
Yeah, I know. Yeah, it's failing. If you've closely looked, and I know there's a lot going on, so it's sometimes hard to spot the right location. Here, there is a progress bar, and that's basically Cypress retrying, until hopefully something changes. And after, by default, 4 seconds, it will fail. But if within these 4 seconds, for example, your AJAX request completes, and something appears on the screen that you're looking for, then this will still work, or will still work.
But you can add tests for different viewports as well.
Yeah, of course.
Okay.
That's what I just did.
Yeah.
And second trick, to just execute this test, just add .only to the test and never check this in. There's an ASLint rule against this, because I'm notoriously I notoriously checked in these .only, and as you can see, there's also some requests that never complete for whatever reason. I think there was another question somewhere. Was it? No. Okay. Yeah.
Thank you. Is there any way to mock some AJAX request?
Yeah, you can do that. We've done that in our project. I can show that later on. Just if I forget, remember me or come to me after the talk. Okay, so much for the simple Cypress usage for your normal website. So as we've seen, it can run against the TYPO3 website. At least I hope the Developer Days website was done in TYPO3. I didn't check that, actually. But yeah, that would be kind of ironic if it wasn't. Yeah, but there's one thing that it probably doesn't, or that doesn't work so well. There is, if you change anything in the database, and that was our main concern with Cypress, with Codeception as well. So I thought there has to be a better way, and I know now that there's also a better way with Codeception. Some people have done similar things to what I do in Codeception, but I've done it with Cypress, and I actually invented a whole new category of tests, and I called them front-end integration tests, which is a fancy name for acceptance tests meet functional tests. Yeah, so what is this? The goal of this is testing isolated front-end functionality, which means one extension or some extensions in your project, or a single extension that you develop that is standalone, and that can be tested in the front end, like you do with functional tests, but just running in the browser. And like the functional tests, they are running against a full TYPO3 system. Like functional tests, there is automated setup and easy reset, because with each iteration, it automatically resets the tests. I would say that's the best of both worlds, at least in my opinion. So how did we do that? The solution is to reuse the functional test setup process, because it's already there, it works. It's just hard to tell Cypress, do this and that. There is a way for Cypress to run, for example, a PHP command, but then both components have to run on the same server. Probably not ideal, would have worked in our case, actually, but I didn't want to do it that way because it really felt dirty. So what I did instead is exchange, if you remember, you maybe haven't been in the talk yesterday, so I'm going to reiterate. So there's a functional test case. It's just not in the tests functional folder anymore. This is the usual functional test setup with the folder and the database. But there's a web server in the equation here, and there's also another extension that basically plays the role of the PHP unit test runner. Because normally the PHP unit test runner uses the testing framework to do all the setup stuff. And in our case, it's an HTTP API endpoint that then somehow does weird magic to convince the testing framework, no, you're actually running in PHP. It's all fine. don't touch the normal database, use this database instead, this one, and then everything somehow works. I didn't manage to crash the system, at least not after the first 2 or 3 iterations. Now it's pretty stable in our case. Yeah, and there's also some alias, Apache alias configuration in this web server, both locally and also in the cloud, which is a fancy name for the VMware cluster of our client, where the tests actually run because they have to use an internal database, so we have to run them in their data center. Yeah, and that's basically the fancy process that is involved. Don't let that scare you. It's actually pretty simple. There's a REST API call, magic in the database, the test system is created, and the data is imported. That's the important step, that we have the same data setup process as in functional tests, so actually works the same. And then we report back the test system ID, ABC1234 in this case. And from that point on, the test system is available with a real URL. Okay, real URL sounds strange in a TYPO3 developer conference. It's available via HTTP. We can also perform a front-end login via a REST API call, because always executing the front-end login form is pretty slow. And then we get back the FE typo user cookie. That's optional in some tests, but other tests always require this. Yeah, and then we can do the usual Cypress visit, rendered page is returned, and we perform tests on that. The usual test cycle. Okay, the setup is actually pretty simple. We've just got one onboarding. Oh, well, I just took one simple example from our project. We've got one test case, a matching page tree that has some pages, some content elements that we need for this test, for this particular test, and also a site mock. Currently, this is a mess of copied and pasted site mocks all around the place in all the extensions that we test. I need to unify that. I just didn't want to put it in the site package, because in my opinion, it doesn't belong there, because then all your packages depend on your site package, while normally your site package depends on all your other packages. So that somehow creates circles that I don't want in my dependencies. Yeah, and the usual, or these tests look pretty similar to what we've just seen. There's just one before task that is executed at the beginning of this context. So all the tests that run will have this executed once before the first test. And this import data basically triggers the import of the data set. Yeah, and then, as usual, we can run our normal tests. So we visit some URL, test if there's a registration button, click that, or no, click something else. No, we click the registration button, and then we click something else on the opening page, and then check. No, we don't click it, we just check something. Should have looked at it beforehand. Yeah, so I'm just gonna demo this kind of tests now. Let me quickly open the So that's the older version of Cypress. No, I upgraded Cypress already. So that's the same. Yeah, and maybe I'll first show the actual test implementation. Because I'm running out of time, I'm not gonna develop that from scratch now. I just show you what it looks like. So this is all of our test case on the server side. There's just one. So we've got this abstract base class front-end integration test case. I need to open presentation mode. Enter presentation mode, yes. Yeah, so we've got this front-end integration test case base class. This is the base class that basically shows us, or that basically signifies via this interface that this is a test case that is meant for Cypress. It's also obvious from the namespace, of course, and then we just import this test data here. And this page tree is actually pretty simple. It's just one page and some TypoScript setup, so we get something output in the front end. And I will just run this test. No, I should show the test first. Yeah, it's just importing this single test class. So I created our own test extension within the project yesterday. And I want to check if the test side shows hello world. And that's basically the test. And I hope it works. Of course, it's not going to work, and I know why. Oh, no, it's working. Why is it working? It shouldn't work. Okay, interesting. Yeah, there's actually a tunnel inside the network of the client running in the background, and that always has to be open. For some reason, it still worked now. Don't question the gods behind that. So I will now to show you. For granted, it's a very simple test case now. We don't have any user interaction that changes things in the database, so we'll just simulate that by changing the data in our fixture data set, or data set fixture, whatever. So I will now not greet the whole world, but only the developer days. And as you can see, I didn't reload the screen, but I just saved my test, and in the background, Cypress already started running the test again. And it's now failing. So I will adjust the data set that is loaded, and I just reload the test, and it works. Because the test data set is reloaded when this request is performed, and then the test can run against the new data set. And yeah, any questions up until now? Otherwise, I will quickly. There's just the summary left, so I'm just going to quickly go over the summary, and then I can also show some real-world data examples, and also some real-world tests, how they look. Yeah, so the summary, Cypress is a great testing tool. I love it. You probably do too by now. And Cypress can actually supercharge the TYPO3 functional tests, in my opinion, because it gives us a new way to test not only our projects, but also simple or single extensions. Because you can basically code or maybe also reuse your functional test setup and just run that in a browser, like any user would do it. You can also use that for testing stuff in the backend. Also tried that. We don't use it widely by now, but it's possible. You can do a backend login. You can validate stuff in the backend. You can also change stuff in the backend via Cypress, and then verify that it actually changes things in the front end. For example, if you want to. And I had another thought, but I lost it, so I'm just going to continue to the next slide. Yeah, so these front-end integration test cases are on the PHP side are basically functional test cases. There's a test system exposed via HTTP after an HTTP call based on this functional test case, and in the JavaScript there's just the spec file with an added setup call, and that's basically it. There's nothing more that you have to change. This setup request goes to our main TYPO3, and all the further requests go to the test system then. Yeah, and that's the setup again. Benefits, we test against isolated systems. The database is automatically reset with each test run. We can also use custom test fixtures, for example, for some special situations. Currently, you can only load one data set, but you could easily implement a method to tell the setup call which additional data sets should be loaded, or additional setup methods in the test that should be called. And you can also, I didn't show that, but you can also use a custom system configuration. For example, with, I don't know, test cases for different database connections and stuff. Yeah, the possibilities are basically endless, like in functional tests. Functional test was the right keyword. Why did I start all this madness? Because one day I discovered that if you run a functional test and get a front-end response, the configuration of this front-end response is slightly different, or the configuration that XBase uses in this request is slightly different from what it uses in the front-end, because functional tests are run on the CLI, and XBase for some weird reason assumes, CLI, that must be backend context, and so it loads the backend configuration and not the front-end configuration. So your storage pit that you set in your front-end is magically gone, and it uses something else, and stuff starts failing. And I just thought, okay, I'm out. That's not my cup of tea. If I want to test in the front-end, I want to test in the front-end, and that's in a browser and not on the CLI. Yeah, thank you. There's a question?
Do you know if you can do automated tests for accessibility reasons like contrast checker with Cypress?
I haven't done that, but I would imagine there is some library somewhere that can do stuff like this. Yeah, but I didn't do that until now. But I guess since it's running in the browser, if you find a way to somehow from JavaScript test things, yeah, most likely yes. Another question?
For this front-end integration testing, what's required except TYPO3 and Cypress? You mentioned this extension, front-end integration. Is it publicly available, this stuff, or
not
is
yet.
it?
Not yet.
Will it?
I guess so, yes.
Okay.
The only caveat is this is all running on version 9.5 now. Don't judge me for this. But yeah, I wouldn't basically need to rewrite it from scratch, because also this import data call is probably a bad name, but yeah, I had other problems to tackle than bad naming. So I would basically rewrite this from scratch, or at least take the code and really rewrite it, or refactor it, and then it could be published. But actually, it's not much code. There's like, I don't know, 200-300 lines of setup code, all in all, and that's probably it. Any more questions?
How do test results look in a CI?
Yes, good question. Let me quickly, I hope I can find them. So Cypress basically has reporters for, or normal JUnit reporters. So we're using GitLab, and I need to find a pipeline that has executed these tests, which is surprisingly difficult. Oh no, there they are, and they worked here, so... Oh, come on. You're kidding me. I need the pipeline number. Yes, so there are the tests. Yeah, as you can see, they are not the fastest in our case. Yeah, so that's basically what the test results look like. I don't actually get what they count as a suite and what they count as the test name. So the test name is basically the combination of all the levels, but the suite is some weird in-between thing, and that should actually just be the test name and not the suite. No, it should be the contexts and not the it part, and here it's the it part. So that doesn't make sense, but yeah. This is basically how we see the reports, but usually I'm not interested, not too much, or not interested in all the details, but I'm just interested in the tests that have failed. And in the same pipeline, in the same merge request, a different pipeline, this job has failed. So we can also look at that. Yeah, so front-end integration has for some reason failed. Let's look at the tests. Yeah, so there were some tests that failed. And they are listed at the top. Yeah, but there are no more details here. But we have artifacts coming from the Cypress job as well. Let's look at the artifacts. No. Yeah, so there was some timeout in some command for some reason. I don't know why. As the next run succeeded, I would probably assume that this is not an error in the test, but just some flakiness in the test. That also happens with Cypress. But as you can see on the top here, it's actually running under a real domain with this addition of FT, functional test, and then the identifier of the test system. And that is actually reachable from the web. There's just an htaccess shield, and these environments are also torn down after the test. So no use in trying to access this. It doesn't exist anymore. But we actually have the same stack here than in our staging system. So we know if it works here, then it will also work in the staging system because the setup is basically identical. Further questions? Okay, thank you. And enjoy the rest of the developer days.
Und bitte.
Yes, welcome to my talk. And first of all, I would give a short introduction of what this talk is about. You will get to learn Aching Ingrid, and I will talk a little bit about pipeline draining and draining services. Maybe that's not what you expected when you hear bringing AI to our data center, but in this presentation we'll come to that point. And first of all, I will explain I'm not an AI specialist. I'm not the guy who is implementing this AI at Mittwald or elsewhere. I'm the head of infrastructure at Mittwald, and I'm the one who brings this kind of ideas to Mittwald and talks about these things and talks to people and then pushes this idea forward. So let me introduce myself. My name is Michael Worobcuk. I'm 42 years old. I'm the head of infrastructure. In my free time, I'm a volunteer firefighter. And important to know is the rest of the family goes to school. That's because my wife is an elementary teacher and my kids go to school as well. And in my free time, I love traveling in big campers. That's what I did 2 weeks ago. I was to South France. This was very hot, but very nice. So, some words about the data center at Mittwald. That's an outside picture, and we have 250 square meters for IT only. That is without adjoining rooms. And at the moment we are driving with 170 kilowatt of cooling power, and we are able to do 350 kilowatt max. And at the moment we provide hosting for around about 210,000 TYPO3 web projects and 400,000 domains. And the data center team consists of 3 full-time employees and 1 apprentice. And they all drive an on-call standby, which is 365 days and 24/7. So whenever an issue rises, something doesn't work as expected, there's a monitoring, and one guy gets up and drives to the data center at Mittwald, and we have a maximum reaction time of 15 minutes for that. And further on, I will tell you why that is. And we are certified ISO 2701, and from the TÜV Rheinland, we are certified as reliable data center. Yes. What is exciting about running a data center? If you think about the data center and the picture from the outside I showed you, one might think, okay, that's a block of concrete and nothing in life can be more boring than working in that block of concrete. But if you look inside, and that's what I provide for you, we are looking inside the data center provider and hoster, you will soon realize there's a special way of working necessary. Because you have to imagine there is no dev, you don't have any quality service, no staging area, no reverting tools or anything else, it's just the live. If you do anything, you do it in live, and you don't have any fallback. And once you started your data center, you will never, like almost never, shut it down until the end of the lifetime, but in between, if everything runs well, you won't shut it off. And then you come to the conclusion it's actually more like a nuclear reactor. If you turn it off too quickly, there will be disaster. And that's important to remember. And one of my favorite things about working in the data center is you can touch it. Like, I love software development, and I know many of you love software development too, but if you run through a data center, you can touch it. You can touch the pipelines, you can open doors, and you can walk through it, and that's a nice thing in the IT working environment. So, it's all about stability and redundancy if you are running a data center. The first day you come in the data center, you open the door, you close the door, you turn the server around, and then you ask yourself, will this run stable? does this have any impact on running this data center? Because you are maybe anxious, or you are thinking about what am I doing here? If you are turning a valve or anything, if you are changing an RPM of a pump, you always ask yourself, will this run stable? Because stability is the key factor for providing services as a data center. And then you ask yourself further on, how do we handle errors, faults and mistakes? Because faults, errors and mistakes will occur, and then you have to handle them. And that's what I will show you. You can't imagine all the errors that will occur, and you have to find a way of handling with errors. And experience is extremely valuable. You have to have an experienced team working for you as a data center provider, because even if you imagine you have a new guy in the team, he's the first day on premise, and then he has a lot of knowledge about water flows, electricity, climatization, everything, then still he doesn't have any experience about the data center and the boundaries of the data center which it will be run in, and this experience is extremely valuable. And sometimes you might want to buy twice, that's because redundancy. Many parts at the data center and all critical parts in our data center are minimum twice or triple, because we drive a minimum n+1 redundancy, or in most cases 2n redundancy. And if you run a stable data center, after a time, you realize that stability does not mean performance. If you are all stable and nothing bad happens, you didn't do anything for performance. But you want to be performant, because otherwise you will be kicked out of the market because you are too expensive. So then you realize innovation is something that needs to be done even in the data center, and there are many points and many issues where you can be innovative, and you always have to remember that performance is important and innovation is important. On this picture you see Olaf. Olaf is the head of the data center team. Greetings to Olaf. Maybe he's doing this right now at this moment. But what I wanted to tell you is, if you want to try something, you do it live or not at all. Be sure about when you change something, you change it in your live environment. So for my story and explanations, and for explaining you my ideas, what we might do at Mittwald, I have to give you a short introduction about how our climatization works. We have two very important domains at running this data center. One domain is electricity. We always want to provide very good electricity for our servers. And the other domain is we want to have a very good climatization for the server room. One example, if we shut off the climatization and don't provide any climatization at all, we have a time window of 35 minutes approximately before the temperature rises so high that the servers will shut off. So 35 minutes is not too much if you want to drive to the data center and then do some kind of reaction. Even if you are on premise, 35 minutes will lead to running and sweating if you are not prepared. So that's why we always prepare. And I will give you an explanation of the climatization. So we have our data center, and on the top of the data center there's a machine called chiller, and this chiller is for cooling water down. It takes warm water and makes this warm water cool. Relatively simple to explain, but if you get in more detail, it gets more complicated, because this chiller has two modes of operation. You can run in a free cooling mode, that is, if the outside temperature is less than the cold water temperature you want to provide. It's easy to imagine. With 20 degrees of outside temperature, you can cool down water from 50 to 45 degrees. But if it's the opposite way, if the water is colder than the outside temperature, like the temperatures we had yesterday, you have to run in another mode of operation, which is called compressor mode, and it works the same as the fridge at your home. The disadvantage is it takes more power, the power consumption increases relatively fast, So you always want to drive in free cooling mode as long as it's possible. And in the inside of the data center, there are climate cabinets. And those climate cabinets are for making or producing cold air. They take the cold water from the chiller and then convert the cold water to cold air. I'll explain how this works later. And the chiller and the climate cabinets build a water cycle. So you push out cold water and then the water gets warmed and it gets back to the chiller and so on. And that's a picture of a climate cabinet we have at Mittwald. And in this climate cabinet right now in front you see the air filter. And behind this air filter there is cooling fins. And these cooling fins are flown through cold water provided by the chillers. And then at the top of the climate cabinet, there are fans, and the fans are taking the hot air from the ceiling, from the data center, and pulling it through these cooling fins and pushing it down the raised floor. The data center has a raised floor, that is, there's a concrete floor, and 80 centimeter above there is a raised floor. And in this area, we are pushing cold air through the data center floor so the servers can consume this cold air then. And there are pipelines and stuff else, but so, yeah. That's how this climate cabinet works. They take the hot air from the ceiling and push it down to the raised floor, and while pushing down, the air gets cooled. And you have two control options for this climate cabinet, two main control options. There are more options, but for this presentation, it's enough to say about two control options. One is the valve position. The valve controls how much cold water rinses through the climate cabinet. And then you have the RPM of the fan, and it controls how much air is pushed through. And with these two control options, you have a high impact on how efficient this climate cabinets works. Yeah. That's the basic stuff, and now I want to tell you a little anecdote of a mistake that happened at Mittwald. And this anecdote is for showing and displaying what kind of errors can occur and how big your fantasy must be to imagine these errors in the preview. So we have restrooms at Mittwald. That's a good thing, I think. Everybody of you knows what restrooms are important for. So these restrooms are connected with a drain pipe. And next to our restroom, the restrooms are in the company building, in the office building, and next to the office building is the data center. And this data center is also connected with a drain pipe. And both are then connected with a piece of Y adapter, where the drain and the sewage gets let out of Mittwald. And the data center has a drain pipe for the condensed water, which occurs at the climate cabinets, and then you can wash your hands, and so that's why we have a drain pipe. And one bad day, the drain pipe from the restrooms got stuck. And the stuck drain pipe from the restrooms is not the best thing for the employees and your colleagues, because you get sad eyes, and there's some kind of pressure, not the project pressure, but some kind of natural pressure you can imagine, and then everybody wants to fix you this problem. So we called the drain pipeline cleaning service, and they sent us a truck. And this truck came to Mittwald, and they started to clean the pipeline. And first of all, they tried to pull, but then this pull request couldn't be confirmed, and the stuck part still stayed there. And then they switched to a push request. They pushed against this pipeline, and the stuck part got stuck, and it didn't move. But what was happened? They pushed the sewage upside in the direction of the data center. And at this place, it came out. So the sewage and the drain water spilled over this concrete floor. It was not a big area, like I know, maybe 3 square meter or 4, I'm not exactly sure, but it was not a big deal. But there's a place with these 2 little pinches in there, and these pinches are moisture sensors. And these moisture sensors are there for a certain task, because when we built this climatization, I showed you we have a circle of water running through it, and the guy who built the circularization, the software developer, then thought, okay, what should happen if we lose water through this water circularization, through this water cycle? Maybe we should stop the pumps from pumping water through it, because we want to prevent more water to spill out. Right now, I would say it's the same like you cut your arm and then you start bleeding, and you don't want to bleed to death, so you stop your heart. That sounds not like a very good idea, but then it is like that. So half of the climatization stopped working, not the whole climatization, but the upper half of the climatization stopped working, because the climate control then said, okay, there's some moisture on the sensor, and then stop it. Yeah, and that's where you start rock and roll in your data center. You start running, you start sweating, and you stop laughing, and you want to fix the problem relatively fast, because nobody wants to stop half of the climatization in your data center. And all because the stack pipeline from the restroom, and the restroom planning was not part of the data center planning, I can tell you. So, yeah. What did we learn from this mistake? We learned that one can learn from mistakes. And you can't take your Glaskugel, I don't know in English, Glaskugel, you know, and see all errors that might occur in future. But it would be best if we keep learning from small and tolerable mistakes, and that's all the time. And it would be great and much better if we had a machine like this roboter that does that for us. Like if we had a machine that always does small mistakes and errors, they are not too big and you don't get in trouble and you can learn from it and you write the learnings down. And that's the point where I came to the idea of bringing AI to our data center. For being clear, this project is not finished, it's not even started. I'm telling you about a project which is a fantasy, a dream, an idea, and we might take this to Midwald, but we might not, it's not clear yet. But I want to give you an inside view of what we are doing and how we handle innovation. So, a little bit more detail about our climatization. It's not too hard, I promise. We have these chillers, you see them, and in these chillers, each chiller has 2 compressors and two pumps for pumping the cold water and doing the compression for like in compressor mode. And they have the connection for the hot water and the cold water. And at each connection, there's a temperature sensor or a temperature commander. For the cold water, you have a temperature commander because you can command or wish the cold water temperature. You can tell the chiller, hey, I want 14 degrees of cold water, please do what you can for providing me 14 degrees of cold water. You can tell every single unit what water temperature you want, and then you get a warm water temperature back and you can read it and do your decisions. And these chillers then are connected to a plate heat exchanger. And these plate heat exchangers themselves are connected to a manifold blocks with pumps. Why is that? Why are we getting so complicated with 2 cycles of water, and what is the sense of that? It's quite simple, but you have to come to it. We have an inside cycle of water, which is all the way in the data center, and we have an outside cycle because the chillers are on the roof of the data center, and we have to get to the outside, so that's where you meet environmental temperatures, And in Germany, these temperatures can drop below 0 degrees. So then your water would get frozen. And we didn't try, but I think we don't want to operate this data center with frozen pipelines. So that's why we add some freezing protection to it. That's the glycol. And this glycol has a big disadvantage because if you spill glycol over plastic or in network cables or everything cables that are in data centers, it's very aggressive and it will eat this cable. And we didn't want to try this either, so that's why we decided to have an inner circle with pure water and an outside circle with glycol. And the water is pushed to the manifold blocks where it is distributed into adjoining rooms, but I will leave that, and the water is then distributed to these climate cabinets. And if you see this whole control picture, there are some logical units in it. And one logical unit are these chillers, because these chillers have a master control from the company who manufactured, from the manufacturer. We got a master control, and this master control is capable of telling all these chillers what they should do for getting a wanted cold water temperature. So you can tell the master control, hey, I want 14 degrees of overall cold water, and you can manage all the small units in there, and I don't have to deal with it. That's comfortable, but the boundaries are the master control doesn't know anything about the outside world. It's just about these chillers. The master control doesn't know there's weather changing or you have the climate cabinets. It's just it. And the next logical units are the pumps with the controllable RPM. And then you have the climate cabinets. At Mittwald we have 6 climate cabinets, and every climate cabinet can be controlled with the RPM for the fans and the valve position. And again, these climate cabinets can talk to each other and they can have a master control, but it's the same thing. The master controls don't know each other. So that brings us to a challenge we always have. And the challenge is, first of all, the system is highly dynamic and is dominated by a constantly changing input variable, and that's the outside temperature. You know, we tried relatively hard and put a lot of effort in fixing the outside temperature at Mittwald, but then we didn't succeed yet. If someone of you managed to fix the outside temperature, tell me how you did, but we didn't get to that point. So the outside temperature is always changing from day to day and from minute to minute, and so is the humidity. The water in the air is also changing all the time, and you have no impact on it. You can control it. You just have to read these values. And then understanding the relation between the controlled variables is mainly important but very hard. If we turn the water temperature 1 degree up, we increase the water temperature, the wanted cold water temperature by 1 degree Kelvin, then one could think, okay, the chiller must put less effort in producing cold water, so the energy consumption might drop. But the climate cabinet, on the other hand, gets more warm water, so the energy consumption might raise. And what's the ratio, what's the relation between it? Is this a good decision to put the water temperature 1 degree up, or is it not? And you have to manually find out, and that's what's really hard. Understanding the relation between the controlled variables and the input variables, and to make these findings reproducible and to describe them with an algorithm, it's very hard. And we didn't manage to do that either. But we did a lot of things that we are already capable of doing. We can operate this system in a stable manner. And that's something I'm quite proud of, because in the last years we had a data center uptime of 100%. That's not true for Mittwald as whole, but for the data center we had an uptime of 100%, and we always had a stable environment in operation. And we have learned from that experience. And what's also true is if someone is new to the team, he must first gain this experience, because I told you the experience is the most valuable thing in this team. And we can show the energy consumption of each individual device, and thus also the total consumption. That's what we are already capable of doing. And now I have a fantasy, I have a dream, I have an idea, I want to do something, and what I want to do is I want to find an octopus and put him in the data center. And the name I would give this octopus is Achim Ingrid. In short, Achim Ingrid would be AI. And then AI should be capable of controlling everything in the data center. He could control everything because he has so many arms and he can do everything at the same time. And yeah, we get good friends. Achim Ingrid and I have a good relationship, and Achim Ingrid wants to help me, and he wants to do energy consumption optimization in our data center. And then Achim Ingrid starts to control everything. He starts to control the wanted cold water temperature. He starts to control the pump RPM, the valve position, quite everything. And AI is quite clever. He is really smart. So he can also watch at the power consumption. And then we can talk to AI and tell him, hey, whatever you do at your control elements, just watch that the power consumption gets better. That means decreases. Less power consumption is better than before. And then whenever you try turning your knobs, look at the power consumption and start to get the better power consumption. And AI can also have limits, because he is not allowed to just turn knobs like he wants to, but he has to watch the server room or cold ISIL temperature. And that's very important. That's the main important thing, because if we have a too hot server room, then the servers start overheating and we shut off our service. That's not what we want to do. So we have to tell AI that he has to look at the limits, and he can read the weather and outside temperature values. Yeah, that would be a great thing and a cool dream. And then what Achim Ingrid should be able to do, he wants to sit in our control room. That's the control room of our data center. And AI should train himself, because I told you he can't imitate us, because these kind of things we don't know ourselves. So then AI should start and train himself. He has to try things out. And one simple strategy AI could use, from my point of view, could be just adjust one slider and see what happens. If the result was good, and good means the limits were met and the KPI improved, so the power consumption, then check at which temperatures these also applies. And then for changing temperatures, if this is also true, then this is a good step in the algorithm, and you can take the next slider and the next step. And if you think of Achim Ingrid doing all these performance optimizations, one could put him in possible modes of operation. One starting point of operation could be Achim Ingrid could make suggestions at the beginning, which are then implemented by the team. Maybe he's not sitting next to the control element, but then he can talk, like Octopus can talk, you know. He talks to us and tells us, hey, I want to adjust this slider like a little bit to the left, and then, oh, that's not good, turn it back to the right. For a testing operation, you know, I tried to gender, that's why it's she needs a limited control range at the beginning. And she could possibly start at an adjoining room with fewer controllers. We also have some, not the big data center, but small rooms where you also have climatization and everything, and she could start in that. Yes. I have to look at the time, okay. Sounds good, no? I think it sounds good, would be a great idea. I'm always looking for octopuses to put in our data center, and if I find one, I just put him in and tell him everything. You know what I mean. We could then start implementing our AI, our computer system, which starts these things. But if you think about it, and that's what we did in our teams, we thought about this idea, of this crazy idea of me, you will get some questions. And one question is, does it even make sense to create a physical model? And does AI need to know the physical relationships? It's wrong, the relations. The physical relations. Should he care or not? Does he be aware of you are pumping cold water through pipelines, or is this totally not of interest? We are not sure. There are different opinions. You have temporal components. What I mean is, if you start changing the temperature at the chillers, the water gets pumped down to the climate cabinets, and there's a lot of water to be pumped down, and then you have a time shift where the effect is committed to the climate cabinets. And how long is this time delay? We didn't measure yet, I'm not sure. Maybe it depends on how much you change the water temperature, or it depends on the outside temperature, could be also. I have experience and I have an idea of how long I would imagine it would take. Like if you ask me, I would tell you maybe half an hour, 1 hour, 2 hours. Yeah, let's say 3 hours. But it's something between half an hour and 3 hours. But that's my experience and my idea how this thing could work. But AI doesn't have this knowledge unless I could tell him. And then what would happen? AI would be aware of, okay, there could be a time delay, and no control input just takes action immediately, so you have time delays, and then he starts turning a knob and waits. And how long should he wait? Like for months or year? I don't know, but you have these temporal components. You have a lot of temporal components there, and I'm not able to describe everything. I just described one short, simple example. Choosing the right strategy would be a big deal. I showed you one strategy, but there are millions of other possibilities. How would AI go back? That's I think it's a quite interesting question. Imagine AI has 2 sliders or 2 knobs he could turn, just 2, and he turns the right one a little bit to the right position. And then he looks at the limits, the server room temperature, and he sees, wasn't a good idea, the temperature rises and we are close to the limit. Maybe I should turn it back to the left, but the temperature doesn't drop, it rises further. And then I start thinking, okay, maybe I take the left knob and turn it to the left, but that has no good impact, it makes things worse. And how should AI be safe, able to go back one step, like to revert the last change? I don't think it's describable or quite sure possible, because you have a dynamic system which always changes. It would be a hard thing to solve. And should AI be able to call for help? Would be an interesting thing. Like, hey, I'm not sure what I did. I'm in panic mode. The temperature rises. I'm not sure what to do. Can anybody help me? And when should he do this? And how should he do this? And what should be the boundaries for this? It's, yeah. I think I got it here. Can we trust AI? I thought, or I told you, in my opinion, it should be my friend, but maybe it's not my friend. It's he's not very happy with with me, and then he starts doing things against us. And how do we check if AI is doing a good job? We think of AI being put in our data center and working for 2 years, and we didn't do anything for controlling AI. Does a good job in our opinion, but then how do we check if AI is quite really good? Or would it be better if we had things done by ourselves? And that's all the technical aspects that were in my head, but there are some managing aspects and organizational aspects as well. And one interesting question could be, can it be worth the effort? My optimistically assumption is we can do 30% improvement of total energy consumption if we use AI. And how do I come to that? It's just fantasy, but if we think of Pareto, then the 80-20 rule, maybe we did 80% of the optimization that is possible, then we have 20% still to go, and I would raise that and say, okay, maybe it's 30% to improve our energy consumption. And then let's look if this would be a good result for the economical aspect. So in 2021, Midwald had a total energy consumption of 1.4 million kilowatt hours per year. And that is, no, not that. And we had a PUE of 1.53. For those who don't know what PUE is, it's a measure of efficiency. You take the total power consumption of your data center and divide it through the power consumption of just the IT. And then you get to know how good your work is. And so that leads to a possible saving of 420,000 kilowatt hours per year, which at the price of 25 cents per kilowatt hour would be a saving of 105,000 euros per year. That's okay. I think if we plan for further 5 to 6, 7, 8 years of operation of our data center, it sounds not too bad. But there's a but. If you look at Google and the PUE, it's 1.2. And if we increase the performance at Midwald of 30% and get from 1.53, 30% off, we would get a PUE of 1.07. That's way better than Google is. I don't think we can get that. I'm an optimistic guy, but yeah, I would not bet on beating Google in driving efficient data centers. And our data center is like 9 or 10 years old. So the best we could possibly get off is 10 to 15% lower than now. And that's a possible saving of 210,000 kilowatt hours per year or 60,000 euros per year. And that's, yeah, that's okay, but that's for AI, that's sad. That's not enough for feeding him all the time and developing him and finding him and talking with him and so. But I have to say that also it's just an idea and a brainstormed idea. It's not a ready solution I wanted to provide you, but I wanted to show you the way of thinking at Midwald and how we handle problems, how we think about it, and how innovation can take place in data centers. And this innovation would be an innovation. And maybe one time we find a way to start this project because the energy prices change, might be, or energy consumption would change, or anything else on the outer boundaries change. So then maybe it's a nice project to start. Yeah, thanks so far. And now we have some questions if you want. And before you start with the question, please raise your hand so I don't know your name. You can go to Jan. Yeah.
Bring your microphone.
We'll bring your microphone and the camera. You can wave.
So you mentioned experience is quite important for people to working in data center, and how long do you think does it take to bring new people up to speed if you're onboarding them into the data center?
I think a realistic time range would be half a year, 1 year. Like, you have to understand the relations of every device, and then you have to get a feeling of these devices. And like a small example would be, we have a site room where all the climatization pipelines run through, and these climatization pipelines are enclosed by the Dämmung, climate insulation, the insulation, yes. And the insulation is important for the pipelines not to build condensed water. And then one time we had a small pinch on the backside of the insulation, which I would never find, never in 10 years, even if I was 2 or 3 hours per day in this room, I would never find this pinch. But the guys from the data center found this pinch because just of, I don't know, maybe some kind of instinct, or we have guys who are really love details, have a detailed way of working, and they found this pinch, and then we could repair it. So it's important to just gain this experience, and then you have to have a feeling for all the machines. Like in the machine room of a marine ship, the guy in there, he has a feeling for the machine, and he knows what click, click, click is okay and what clack, clack, clack is not okay. And that's the same with us.
You have the power consumption level of Google. Do you know how much automatization other data centers have included in the process? I wouldn't have guessed that there's so manual factor.
Yeah, I was able to visit some other data centers, not all data centers of the world and not all data centers of Google, but in my opinion, we have a quite good amount of automation, because you can choose two ways of building a data center. You can take a mixture of both ways, but then the both ways would be you take from the store. You go to a climatization store and tell them, hey, I want cold air, and I want this done by cold water. And then they sell you cold water machines and cold air machines. Or you can start doing things by your own. And I visited a data center who just didn't let the guy from the store in and said, no, I don't want to buy from the store, I want to do it myself. And they had great results too, but then they had other problems like Kinderkrankheiten, children illness. I don't know. Yeah, and I think it's hard to automate everything, because then you come close to AI. Yeah. Which I would love to reach. No? Any other further questions, or just hunger? Okay, then the last one. Thanks for joining.
Yeah, hello everybody. Warm welcome from my side. Hope you enjoyed your lunch. Welcome to the session Multi-Stage TYPO3 Setup at an Autoscaling Multi-Instance Cloud Environment. I think we are quite sure who will win the Buzzword Bingo award these days with a catchy, fancy title. It's me. My name is Tobias Hein. I'm from Net Research, TYPO3 and Magento agency in Leipzig. And I'm head of operations there, and the digital experience team realized the TYPO3 projects for our clients and do the support for them in long-time support contracts. What we are going to do today. First of all, I want to start to give you a little why. So what drove us to come up with a multi-stage, multi-instance setup. Short insight of our strategy. So what was our idea how to tackle this project, and then a lot of what. So we will come across a lot of tools and a lot of things just to show you how we created this environment, and afterwards we want to speak about some pitfalls we came across just to share them with you if you have the same idea. Maybe you do not the same mistakes and can skip them fast. And afterwards I'm glad to take your questions and maybe we can discuss it a bit. Okay, let's start with the why. As often in agency life, the why is most likely a client who has requirements. And we got a client who had a requirement of a multi-stage TYPO3 environment with a stage system, an integration system, and a live system. He had a quite ambitious forecast for traffic. So starting from 2 million page requests per year, we are now at around about 12 to 15 million page requests per year. Sorry, question? Where's the microphone?
In your setup, what's the difference between the stage system and the integration system?
I will come to that. The integration system is for testing new plugins and features by the client, and the stage system is the editor system where the editors manage and maintain the content. But we'll come to this in a few slides. Beside this traffic forecast, we had a bunch of security requirements regarding access control, audit, stuff like this, isolation of networks. And the client asked us to do the full patch management, including all services we need to run our TYPO3, as well as the underlying infrastructure. That was the client side, and we have 20 or 50 years experience of multi-stage TYPO3 systems using this by for different clients. And the advantages from our side are clear. You have an independent editor instance. So the editors had a kind of sandbox where they can add content, delete content, totally safe because it's not a production environment. They need no backend access to the production environment. So you have nobody who can, by accident, delete any content element or flushes caches to decrease performance or something like this. And you can use different scalings, sizings, and configuration sets for your different stages. For example, an editor's instance maybe need a bigger PHP upload size for uploading images and stuff. Production does not need it. Production has the images at the end, and you would never load up a large file in production. And regarding the independent editor instance, you of course need a process to publish your content from the editor instance to your production instance. And this is a kind of, we had the question lately, who uses workspaces? And it's a kind of workspace because somebody needs to actively sync content to the production system. So it's not quite likely that you sync something by accident because you have to trigger a dedicated process for it. That's the multi-stage view. The multi-instance view, I think it's quite obvious. As soon as you're running on multi-instances, this doesn't matter if you have 1, 2, or 20 instances. And you can handle performance peaks, increasing requests very easy. As soon as you're talking about multi-instances, you of course need a load balancer. And the load balancer has the advantage that you have a kind of central access control for your request. So on this point, you can already start to block requests to, for example, restrict access to the TYPO3 backend for the front-end system. That's in the nature of multi-instance systems. And in our case, we also decided to distinguish between front-end and back-end instances. So we will see later that our container setup for front-end instances is a little bit different than for back-end instances, which also helps to save performance, to only deploy stuff in your production environment you really need, and we will come to this later. Okay, so fast the why. Let's come quick to the how. So we got this request and we thought about how we can tackle it. And we discussed some maybe quite easy to see points, but I always like to have it written. Of course, we want to use the best CMS in the world, TYPO3, to provide it to our client. We committed to use modern toolset, which means a kind of what is the best-in-class software for solution of one problem at the moment. If we're talking about a lot of instances you have to manage, we clearly committed to use a lot of automation to not do it manually. So nobody wants to stop or start instances or set them up manually. And all together applied to the everything as code paradigm. So not only TYPO3, not only its extension, but the configuration of TYPO3, the configuration of our infrastructure, and the whole infrastructure description should be stored and audited within a central repository or multiple central repositories. And the last thing we thought about was to be as cloud agnostic as possible. You always have this vendor login discussion, and we could not avoid it totally, but using the right tools, you can quite easily switch the setup to other cloud providers. We will see later. Okay, so far, the how. And now the interesting part, the what. So what did we do to come to this fuzzy, neat title of this session? First of all, short overview of our toolbox. Known, I guess most of this is known by you. For running TYPO3, we use, of course, PHP TYPO3 engines and MariaDB, all contained locally with Docker. We use AWS Fargate as infrastructure layer for the client systems. We use Terraform as provisioning tool for the whole AWS infrastructure. And last but not least, Vault as security credential manager to inject our credentials during the deployments, to not need to store them, no idea, in the repository or on some lonely files on any server. And the CI/CD is done with Concur CI in this case, so the whole building and deployment process is set up as Concur CI pipelines. Okay, having the toolbox, that is the multi-stage setup we want to achieve. So VPC is a virtual private cloud. It's the name AWS uses for its virtual private clouds. You can just imagine as a secured network segment where you can deploy your infrastructure to. The requirement were 3 different systems: an integration system for checking new features, get approved from the client, and bring it to the stage system, which is the editor system, where the backend editors can safely change and delete and whatever and try things out for their page. So from this point of view, the stage system from an editor point of view is a production system, if you like. And we have the production system, which then serves the content to our visitors, to our website visitors. Okay, let's dive into it. What's required in such a VPC to run a TYPO3? That is more likely the inside of the VPC. It's a network segment you can access by an internet gateway, and the internet gateway talks to a load balancer. The load balancer talks to NAT gateway, which translates your request to the private subnets within AWS, and speaks with our Fargate cluster. That's the orange mesh you see in the middle of the map. And to run our TYPO3, we need, of course, a database, which is an RDS instance in AWS, and we need a Redis cache storage for our caches, which is also a service provided by AWS. And all of these components are reachable by different private subnets, so you have different routes through the VPC, just in case one of the networks fails, you have a failover to reach your systems. That's more or less the service blueprint, but you may notice nothing of this component still running some TYPO3. It's just services storing data and a cluster, we do not know really what it does at the moment. So let's dive into this. Oh, sorry, I missed that one. The next slide just shows you how we provisioned this infrastructure. We use Terraform, I told you, and it's just a compressed snippet from our Terraform files, this simple text files, where you find the resources you want to provision. Here you can see an elastic cache cluster we provisioned. We provisioned a database instance, and Terraform provides all these resources. They are named AWS, whatever resource you need. You gave them a name and tons of parameters to configure them. I do not put them here because the documentation of Terraform is very, very well. It's fantastic. You have all parameters. They're quite easy to understand, and you can easily configure them. One thing to mention is that you might see here the variables. This is where the magic happens, that we have different stages. So the Terraform Office workspaces, which is something like a branch, if you like. So we have a live workspace, and a stage workspace, and an integration workspace. And each workspace generates the whole defined infrastructure in a single VPC. So you have, with this variable, you can create tons of copies of this setup. After database instance and Redis cluster, we saw a ECS cluster in the last file. That's the third point, and the last point of this in this file is the load balancer. And if this is defined and you tied it up like the documentation requires, then you just run a Terraform plan. That's the execute command of Terraform, and then Terraform creates these resources in your AWS account. So you can all do this work manually in your AWS account by the AWS console, but we won't do this because we are lazy and we couldn't memory all the stuff we need to do. So it's tied up in our Terraform files, and as soon as we apply the elastic cluster resource, we get 3 clusters in our AWS account. We apply the database instance, we get 3 database instances. We apply our ECS cluster, we get 3 ECS cluster, and you might guess what we get as soon as we apply the load balancer. We get 3 load balancers. And this is our multi-stage setup from a required components view. But still, no one said something about TYPO3. No, no TYPO3 application running, no PHP. So we prepared the satellite infrastructure somehow, if you like, and now it's time to get our TYPO3 running. And where is it running? Inside our ECS cluster. And that's the next slide. That's the container view of the ECS service. If you define one task there, that's what we want to achieve, and we will see on the following slides how we did that. We have 6 containers running here. A prepare Fargate container, I will explain you later why we need this. It's in the challenges section. Yeah, the app image holds our TYPO3 code, including our extensions. The setup container does some post-deployment steps we already need after deployment or post-deployment. We need a runtime for TYPO3. We need a web server runtime, which is Nginx in this case. And we need a cron to execute our, for example, TYPO3 scheduler. So that's where we want to come to. Now is the question, what do we need to get to this container definition? The good news is just files and Terraform, and you need a definition of your container. So, as you may know it from the service section of the compose file, which is the name of your container, what's the image. You need to orchestrate these container definitions to one one container definition the AWS API understands, and then you need the data structure in AWS is named task. You need this task definition, which is running the whole container configuration. I brought you our Nginx JSON, which is a little bit shortened, but I think the most points will come out. The Nginx container needs a name. We need an image. We use variables here to easy change it, but at least you can imagine this is the repository URL you should pull the image from. You can define the dependencies. In this case, Nginx needs to wait for PHP FPM because PHP FPM is the upstream of Nginx. You have port mappings, and I think if you work with Docker Compose a lot, you see it's quite the same naming. It's JSON instead of YAML. The mention point is the mount point section. It relates to the volume section of a Docker Compose file. Here you just define which data from which other images you want to include in your container. And in this case, it's the web server directory we need here to have Nginx access to. And the last point is the memory reservation, which just defines how many memory is the container allowed to consume before it's killed. It's just a limit, if you like, to avoid that the container goes totally crazy and eats up all your RAM on within your task. Okay, now you have to imagine we have an PHP JSON, we have an application JSON, we have a setup container JSON. So each container has its JSON file. We just splitted them because it's easier to maintain and you have a more clearly Git history of changes to that. You can all put this in one file, but if you change 10 containers in one file, it might get a bit ugly to review changes. Okay, so what we do then in Terraform is just a little string magic. We simply join the templates or the JSON files we already spoke about into one JSON string. Why do we use templates here? If you remember, we had the variable in this JSON file, and the template just replaces this variable with the registry entry, for example. So after rendering the template, we have all variables replaced and just joining them together to one container definition string. In this case, it's our container definition of our backend service. And as you see, the templates matches the container we saw on the first slide of this section. So you have a template for prepare Fargate, and template for the app, and template for the PHP FDM, etc. So good to go. We defined our containers, we orchestrated them together, and now we just have to tell AWS, please launch this in your environment. And that comes back to Terraform. Terraform knows a resource named AWS ECS task definition. And this is, if you like, the server the containers are started in. It's not a physical server, but it's described as environment. That's why you specify, for example, CPU and memory here, and that is the overall memory for all your containers running in this task. So if you have 5 containers running in this task containing 2 GB of RAM, the task has to have at least 10 GB because the requirements of all containers needs to be fulfilled by this task. And last but not least, we pass our JSON file, our container definition of the backend, to this task, and after running Terraform apply, in best case, the infrastructure should look something like this. We have our virtual private cloud, we already set up our load balancer, and we have our ECS cluster with one backend task running with our PHP container Nginx cron and app. Maybe someone missed the prepare Fargate or setup container. They are not named because they are terminated as soon as they are done. No running service, it's just commands they execute, so they are not permanently running in the task. And I see it, the app should be included as well because it's not running, but that's basically the container stack. Besides this backend configuration, we have another configuration for front-end tasks, so we can launch TYPO3 front-end instances, and they left out the cron container because we do not need it there. They're just there to serve content from TYPO3. They need not to run, for example, schedule tasks in the backend. And if you remember, we already applied MySQL database, and we open up the protected networks that the cluster can reach MySQL port, for example. We already provided Redis and give backend and frontend containers access to it. And at this point, we already can start to, oh, I always miss the EFS cluster. The last thing we provided is an EFS to the containers. It's the elastic file system of Amazon. You can share between these container instances, e.g. for file admin files. So you have one central storage comparable to NFS or something. And at this point, we can start to put some backend editor traffic to our stage. And we provided a dedicated backend domain. The load balancer knows that this domain should be forwarded to the backend instance, and that's where the editor can start, edit content, run cron hubs, something like this. And as soon as he is ready, he can publish the content to production, and then we add some client traffic, maybe some mobile traffic, and the load balancer knows that the traffic of the requests of the front-end domain should only be forwarded to our front-end tasks. Of course, the load balancer would rotate the requests round robin or something to all front-end tasks, but I guess there are enough errors in this, in this slide, so I left that out. And last but not least, to decrease the request amount of our instances, we added in cloud distribution network, a content distribution network, the CloudFront CDN of Amazon in this case, which fulfills the asset and image requests of our for our clients. So this request, the CDN just has one of the front-end tasks as origin, pulls them there and caches them and provided them to our clients. So we reduce the amount of requests to our running tasks. Okay, that's basically the whole setup. And if we go back to the title, we talked about multi-instance somehow, so we can check this. We talked about multi-stage, can check this as well. But I was so keen to write autoscaling to that, also to the title, so that's the point we miss now. And autoscaling is quite easy with an ECS cluster because it's also just a configuration question. And I brought you a Terraform snippet again. This is just if you like, an array. It looks a little bit like TypeScript, where we, on a central place, can define our settings for autoscaling. So, question, sorry? One moment, the microphone, can someone serve the microphone to the...
Thank you. The tasks on the previous slides, those are instances, right?
If you like, their service AWS provides, yes. It's
okay, but it's in a way it's a machine, virtual machine, in some or.
Yeah, I don't know what Amazon uses under the hood, but it's.
Okay, so
it's as you have different servers running where all the same type of size running on.
It's a service.
Yeah.
Okay, thanks.
It's a service, and that's the good part on ECS. The underlying hardware. With all patches is changed frequently. You always get the newest software updates for the underlying hardware. So the requirement of hosting or maintaining the hosts is done by the ECS cluster. So, okay, sorry, sometimes I'm so into I do not see the hands. Just give me a call if I don't see it. Autoscaling. As mentioned, this is some part of our Terraform file, just taking up some variables. It's nothing Terraform special, it's just the definition of an array. And what do we need for an autoscaling? We need a metric we want to autoscale by. In our case, it's the CPU utilization. It's always a good idea to specify a limit for autoscaling, because otherwise Amazon will get a lot of money from you if they decide to span you up to 100 or 2,000 instances. You're only protected by Amazon limits you have to, to get over. And then there are a lot of other quite self-explaining stuff, self-explaining variables. You have an adjustment type, which just says what should happen if your metric is validated. And in our case, we want to change the capacity of our front-end cluster, for example, from 2 to 3 instances, or from 2 to 4 instances. And then you need to define a scale-up and scale-down an operator. So you define threshold for upscaling 80% of CPU utilization, for downscaling 40%, and that's just the operator, you compare those values. So as soon as the CPU utilization crosses 80%, that's our trigger for upscaling, and as soon as the CPU utilization falls to 40%, this is our trigger for downscaling. And then you just need to find the correct Terraform resources, and the documentation of Amazon is also quite well to set up autoscaling, and then you need to find the matching resource, and you define first you define an alarm, a CloudWatch alarm. CloudWatch is the matrix system of AWS, so it takes care to see, is CPU utilization about 80%? And if it is, it just triggers an event. Nothing to do with autoscaling, it just says your metric has been crossed. The same you need for downscaling. So you need a downscaling alarm. You have to define which is the target of your scaling action. In our case, it's our ECS cluster. So you use this AWS app autoscaling target to define this is the target for our autoscaling. And at least you take the policy resource for up and down scaling and define an up and down scaling policy, which ties those three above together. So the downscaling policies just say, if there's a cloud metric scale down alarm, scale down our cluster according to our variables we defined on the first page. The same stuff is done by the upscaling the other way around. If upscale alarm is triggered, please do the following action in our ECS cluster. So that's in a nutshell. At least documentation is quite good, but it does not need more than an existing cluster and these 5 resources to get autoscaling defined. That's basically how we achieved our vision of this multi-stage, multi-instance setup. And now we come to the challenges. You might already expect that there were some challenges, and I put the highlights for you, just that you see what are the things you can fail over during such a process. And I clustered it a bit. Let's start with some performance stuff. Or everybody thinks we are in the cloud, performance is quite good, but even in cloud, if you have a lot of compute power, performance is still a problem because it not always relies on hardware. One special problem we had was the storage system. As we started the project, ECS was not able to attach elastic file system to a cluster. So we needed to use S3. Simple storage service is also an AWS service to store our images. And thanks to everyone who takes care about the FIL, available since 6.2, it was easy because there are drivers out there to run TYPO3 with S3 backend. Our problem was the requests to get metadata to save stuff adds a lot of overhead, especially in the backend. If you create all the sneaky preview stuff, that leads to a very slow backend performance, and we were very glad to see that since April 2020, we easily can add an EFS, which more or less acts like a simple file system attached to TYPO3, so you can go back to the default driver and get rid of all this overhead. The second performance problem is a little bit special because the client had a data import from a mailbox interface. Please don't laugh, that's true out there. There are systems sending their data to some mailboxes, and the client expects the agency to get the data from there. And we get a problem that the access to this IMAP mailbox was horribly slow because we had to update it every 2 minutes. And at least the handshakes and all this stuff terribly. And we addressed this by using the Amazon simple email service, which is just a mail server, but he's able to send the email to a Lambda function. Lambda in AWS is a serverless function. You can define a function which is run when the Lambda function is called, and this Lambda function just puts the data from the mail to a database, and we can do all our processing on the separate database after this import has been done. That gave a lot of stability. It decreases the load and the CPU the backend needed to process all the stuff, and that was an interesting way to get there because we couldn't convince the client to wrap this service behind an API or something. They rely on it's sent per email, but that's our life. Configuration challenges. you might guess is adjusting the autoscaling is quite, is always, it seems quite handy to configure it, but it's always a question which metric is relevant for your application to trigger the upscaling. We took CPU usage, but if you have a real CPU heavy application, maybe it's okay that the CPU is over 80%. If you take memory, it also depends on the profile of your application. How many memory does it consume? There are tons of other options. You can use requests per instance, response time, and we are still playing around with this. That's the point where a right solution is try and error. And even the timings. So you scale up your system. How long do you wait to check if the metric consolidates? If you wait 1 second, you might to launch 10 instances, and you don't give the system the time to consume these new instances, and then maybe you get a totally unwanted autoscaling behavior. So that's fun to play with it, and we are still searching for the optimal solution, but at the moment we are quite okay with what we have. That's the point where I come back to the prepare Fargate container. AWS intern problem is as soon as you run your container in an ECS task, you have no name resolution. So PHP has configured to, Nginx has configured to talk to PHP FPM, but it does not know how to resolve this name. So our quick fix was to come up with this prepare Fargate container and just give him the information that all these services are reachable by localhost, and then the name resolution worked. But it's not that good document, so it took us a while to come with this effort. And the last thing, which is not really a configuration thing, but a quite good challenge, there's no SSH access to any of the services. There's no chance to log in, make some stuff by hand, which sounds weird if you used to just go to your server and fix stuff, but which is a great challenge because, of course, it improves security. You have no need of rotating users, rotating keys, stuff like this. And it forces you to think all details of your whole application deployment process and to automate them as much as possible. And that's a great thing. Sometimes you think it would be great to simply jump in and make it by hand, but you're always forced to find an automated solution, which really helps to keep the quality of the project. And now the application parts, just the top 3, I think. One problem we had was in the beginning of the project that the custom CSS file was generated with a timestamp. So you have maybe you know this, there are, I'm not sure if it's a timestamp, please nail me on that, but there's a string on the CSS or JavaScript file which indicates the system stored it, and that's the version of the file. The problem is each instance generates its own version of this string, and the first instance which writes the cache to TYPO3 just writes his string to the cache, and the second instance just says, sorry, I'm not aware of this file. So here's your page, but don't ask me how it looks. So that's that was also quite a specific thing in a multi-cluster environment, because if we're running one instance, that's no problem. You have one source of that. And of course, you can come over this with CDN and stuff, but also if you define the fluid origins for the CDN, it can happen that it hits the wrong server and could not refresh the file there. So we need to come up with a solution to ensure that the file name is the same on every instance. And in our case, we simply added the release tag as a parameter of our template extension. So we know this file only changes if our template extension is released, and that's the way the file is now generated on the systems, and it's available on every system. Caching configuration, as you might expect, because due to this instances coming and going and deleting and raising, you could not really rely on persistence in these instances, because if you have all your caches stored locally, every upcoming instance have to initiate all its caches multiple times. That might be handy with 3 instances, but if you come to 15 instances, it costs a lot of time. So another thank you to the TYPO3 community and developers and core developers, because the caching framework just allows you to almost store every cache to Redis, and so you have a central instance where all running instances can use cache from. the other side is, not all caches are stored in Redis. We had a lot of trouble with storing, for example, the class loader in cache in Redis. So there are some caches we decided to kept in file system, but that's a downside we can live with because, yeah, storing class loader cache in Redis always throws up the whole TYPO3 side. No, I couldn't solve it until now, but that's something we came across. And the last change, or last problem, and that's maybe the problem of the, yeah, no, wrong one. TYPO3 image processing, also a problem because we had a lot of breakpoints and we used SMS responsive to define the different image sizes. And if the image changes, they have to, the variants have to proceed it and generate it. And the first request always generates all variants of the image. So if you have a desktop request, he also have to wait for all mobile images to be generated. And due to in combination with S3 and performance, horribly slow. So it was good to switch back to EFS as file system. And in addition, we wrote a custom 404 handler for images, so that not all images are generated by the request, but only the one which is requested by the current browser. So the whole time is shared by all different devices and not the first coming has to wait all the time. And the last problem is, of course, the sync of the content between the stages. And if you got my colleague this morning, we use NRSync for that to give the editors and backend the possibility to transfer the content to the production instance. What's the summary of this? TYPO3 is an amazing CMS, I think we can apply on this, which is 95% ready for multi-instance environments. If you do that, centralize your data to dedicated services as much as possible. So if you have a service with their own persistence, that's something which needs not to take place on your different TYPO3 instances. Thanks to everyone who's working on abstraction in TYPO3, that's a great benefit because without caching framework and without FRL, if I imagine that we had to implement it with DAM, I'm not sure if this is possible at all. Automate your process wherever possible. So, and if you have no access, you're forced to. That's a good point. And then be aware of the tiny little pitfalls and have fun with things you didn't expect as long as you run TYPO3 on a single instance. Thank you. And now I'm glad to take your questions if you have someone. Thank you for attention. Yeah.
As you are, of course, trying to automate things, I expect everything to be rolled out through CI in some kind.
Exactly. I had some CI slides in it, but as I heard 30 minutes only, I put them out. We had pipelines for building the images, Concur CI pipelines, and for deploying as well.
My question is, where do you store your Terraform state files, because they are important to remain consistency.
Yeah, we use the Terraform Cloud State at the moment, but I think GitLab is able to store Terraform state in some version, I guess the latest versions, and we plan to switch to GitLab in this state because it's in our hand at this time.
Okay, I have a second question, if okay. At the slide you had regarding their entire setup, regarding the BE, backend, front-end, load balancer, etc., you had their load balancer and the CDN at the same level, like the CDN or the load balancer asked the CDN and not the CDN the load balancer. Is that a mistake or is it on purpose?
No, it's the flow of the request. So the CDN asks the load balancer go to the front-end task to the EFS, and all this data running back to the CDN.
Okay, then I just misunderstood the setup.
That it's included in the VPC is only a problem of space because the VPC goes down to the side.
Fair, then I just misunderstood it.
But good question, thank you. Anyone else?
Are you using front-end logins in any way?
Yes, we have a protected space where agencies, for example, can log in, yes.
And did you run into any problems concerning front-end logins being available to all instances? So when someone logs in on the first task and then gets switched to the other by the load balancer?
No, because the sessions are stored in Redis. And so the session is available for every instance, and then you have basically no problems with the session.
Okay, another question. Do the front-end tasks share the same database, or do they all have their own instance?
No, they share the same database. Okay. Otherwise, the setup would get too complex to handle, because you need to forward and backset, especially the session data. So you need one session data stored in Redis, but I will not think about which problems will occur if you have dedicated databases.
Thank you.
In the front?
In your overview, you had one backend instance and multiple frontend instances. How do you handle caching for like pages? So if you are in your backend instance and clear the cache for pages, that the frontend instances also update the content.
Due to this slight design, we had backend and frontend instance in one VPC, but the frontend, the backend instance, the editor's work is in another VPC than the one the production services run in. So it's not expected that an editor go to the production backend and clears cache there. It just happens in the editor instance. So you do not have the problem that the editors clear your production cache.
Yeah, I didn't mean for the production, but for their stage environment itself. So if they want to see...
They share the same Redis, so if they clear the cache in backend, but then it's gone for the front-end instances as well. But it's not that problematic for the editors, because they just take the preview, and if you like, it's the same behavior you would have on a single instance, because in a single instance, if you
okay, they are also working on a single instance and not having the front-end scale at this point.
We have a fixed count there. We do not scale the stage environment, has just front-end instances to have the same setup, but we have them fixed to 2 just to test the load balancing there. Autoscaling is just enabled for the production environment. Over there.
What was the reason why you chose ECS service over EKS service on Amazon? Can you explain that?
As we started, I think the EKS service wasn't available yet. And we only had this choice between ECS, which is the self-managed. You provision all the instances by yourself, have to manage the OS patches on the system. And Fargate is another layer about it, so you can leave out all the OS patching and just care about your containers, and AWS takes care about the underlying ECS infrastructure. So I think, I'm not that deep in EKS, but I think the complexity is a little bit lower in AWS Fargate, and I'm not quite sure if EKS takes care about instance OS patch management. That's I'm not deep enough into, but the complexity level and learning curve was not that big, I think. But if someone wants to translate it to EKS, I would like to get a presentation next year how it's done. Okay, great. Thank you. Have a good day.
Hello. Hello, everyone. Today I want to present new APIs in TYPO3 version 12. So basically the ones we have until now, as you have heard by Benny Mack's keynote 2 days ago. The 12.0 release will be in October, and feature freeze will be next year, I think in March. So there's still some time for new APIs, but some we did some already in the past few months. So let me show you today's agenda. First of all, I want to introduce myself. Then we want to have a short look regarding what is an API, and in the context of TYPO3. The next thing is the main part, what is actually new, what are the new APIs, and last point is what's next. So we already have something in the pipeline, we are working on stuff, and I want to present something of that. Okay, so to me, I'm Oliver Bartsch. I am working at B13 in Stuttgart. I do mainly core development next to customer work. I'm part of the core development team since last year. And next to this kind of stuff, I do also things in the TYPO3 ecosystem. So basically, if you have published an extension in the last couple of months, automatically via GitHub or GitLab, you usually have something used like the SOAP API or the REST API with Taylor, a CLI tool to communicate with this REST API. And yeah, I'm working on this also. And if you want to get in contact with me, you can contact me on Slack or on Twitter. Okay, so enough to me. Now let's talk about APIs. What is an API in general? So an API is basically just a term for communication between systems. This means this is not communication user to system, but system to system in a defined way, usually documented in some kind of definition, API specification or stuff like that. So the underlying business logic of each software system is not known to the outside, so they just communicate over the defined way. I think most of you know what an API is. So, and coming back to the REST API I talked about in the last minute, that's exactly that. We wrote the Taylor API tool for GitHub, and this tool talks to the REST API on TYPO3 org side, and they talk with the specification, and they don't know anything about their internal work. Okay, so, and what does now API mean in terms of TYPO3? I did some quote, and I would say it enables developers to extend and customize the system to their customer needs. So basically in TYPO3, the API means everything which somehow changes the default behavior. So if you want to add a new field to TT content or anything like that, this could be themed as an API. Okay, and main part, interesting part. So what's new? I have 5 areas which I want to present. 5 areas where stuff was introduced or improved, because I think it's also important to mention something which was already there and is now improved, is better, easier to use. The 5 areas are PSA13 events, TCA types and options, auto configuration and auto registration, backend modules, and last point, backend templates. And let's start with PSA13 events. Maybe you remember this guy and his talk on the last Dev Days. This is Benny Mack, and he held the talk, Don't Get Hooked, Listen to Events. This was when he introduced PSA13 events to TYPO3 version 10. And a lot of stuff happened since then. Basically, first of all, we replaced all the signal slots from XBase with PSA13 events, and also started in version 11 with replacing hooks with PSA13 events. And yeah, in version 12, we already did around 30 PSA13 events added. Yeah, the same amount of hooks got removed, or replaced better. But we did not only replace hooks, but also introduce new events. If you have a look to the changelog already, you think, oh, TYPO3 version 12, a lot of breaking changes, but actually we just documented every hook we replaced with an event as breaking change because the hook is gone. But we have kind of backwards compatibility strategy. So if you want to support version 11 and version 12, you can just implement the hook and the event in both. So both versions can be used with the same extension version. Yeah, events we introduced. This one I don't want to show every event, just to get a short overview. This is the list of new events. So let me just show 3 of them. Or better, sorry. First of all, let me come back to tell what the reason is for introducing events in general, and why do we replace the hooks. Most of the time, the main goal was not only to just replace the hooks one by one, but to replace them with an improved PSA13 event. And additionally, as I already said, we added more events. We simplified the usage and registration. You remember mainly for example, record list hook interface. So if you want to change something in the record list, you had to implement this interface, this interface for your hook, which required you to implement 4 methods. I think make clip was one of them, make control, and stuff like that, when you only need one. So the reason also for PSA13 events is the usage and registration should be easier. Also the unified structure of the events, so every event basically looks the same. So you have always the getter, where you can access information like the current request, and you also have always at least one setter, where you can adjust some object or array in this event. Okay, there may be also events which just say, okay, something happens, you can now react on this, but that's not the main reason for events, because this is more than a task for webhooks or reactions. And yeah, provide an object-oriented access to array stuff. So TYPO3 implements really much arrays, which is often hard to find the right information. And we wrap this in events to have an object-oriented access. Yeah, I will show 3 events, 3 examples. This first event is a new event after page 3 items prepared event. It provides the current PSA13 request. Oh, it provides the current PSA13 request. Is triggered after TYPO3 calculated the pages for the page tree, and before they get sent to for example, if you ask with an AJAX request before they are sent as JSON response. So the event also contains the complete page record, and this is important because basically the page tree items you can adjust not the records itself, but the information needed for the page tree, for example, the icon, or if it has an overlay. And this can be adjusted, and you can use the page record and don't have to fetch it yourself. The next event I want to show is modify page link configuration event. This is an example for an event which replaces an existing hook. Typo link modify parameter for page links hook. Yeah, it was improved to fully replace the resolved page link, so you could completely add another link than the actually resolved one. You can also just manipulate the typo script configuration, which is the base for the page link which is resolved. And you could also manipulate the query parameters and the fragments of the link. Last event I want to show is modify new content element wizard items event. I want to show this event because it also replaced an existing hook. But it is improved in a way that you are now able to, for example, change the position of items in the new content element wizard. So you can say, I want to have this content element before this content element. You can also manipulate the whole wizard item configuration. So you could add additional TT containing default values, for example, directly fill a field or stuff like that. And yeah, also built-in convenience features. This is something like you can ask the event has wizard item, so you can check if there is already a wizard item with this key, and you can remove a wizard item, and you can set a new wizard item, and yeah, the convenience features like set, get, has are implemented. Okay. Next topic is TCA types and options. The main benefit of this API is we have around 50% less configuration effort for you because we can, with the dedicated types, there is not this much configuration needed because TYPO3 internally knows exactly what this type is for. And also defaults can be used. Yeah, the main thing we replaced is type input, because type input had so much different use cases. So there were render type with a lot of options. There is the eval option with a lot of possible values. So it's really hard to find out what this input field is really for. In TYPO3 core, we had so much string checks, which check the comma separated eval list to get functionality out of it. You have 100% more clarity if you have a dedicated type. Yeah. Okay, so which TCA types were introduced? The first one is type password. Type password replaces eval password and eval salted password of type input. A migration looks simply like that. You had first type input with eval trim password salted password, and this can easily be migrated to just type password. You don't need trim anymore because this is done automatically. And you also have password as the type. Salted password just does or said that the password should be hashed. This is also the default. What I said before, you don't have to configure this explicitly because you can say, okay, type password does this automatically. If you don't want to hash the password, which is always a bad idea, you could set hashed false. Next new TCA type is datetime. This is a great datetime to show what is also possible. First of all, it replaces the render type input datetime of type input. And one of the main benefits of this new type is you don't have to create the database field for this field anymore. Like the management fields you already know, fields of this type are automatically created. So you can still override it in your tables SQL file, but based on the TCA configuration, TYPO3 does create this table field automatically. The migration looks, for example, like this. You have input type, type input, render type input date, eval date int with default null, and this can be migrated just to type datetime with format date and default 0. Eval int is set automatically if no specific DB type is defined. DB type is if you want to use a native datetime database field, not in this example included. And the format, yeah, is just defines how form engine should render this field. So if you say date, you can select a date. If you, what would be the default, that's why I did not use it here. Datetime is the default, so if you don't define format, then you have the usual datetime picker. Next new type is number. It replaces eval int and eval double2 of type input. Migration looks like this. Type input, eval int is migrated to type number. And double, also eval double, is just migrated to formal decimal. Yeah, as you saw in the last migration, format is also defaults to integer. That's why you don't have to configure it if you would like to use integer and not double or decimal. Next type, new type is link. It replaces render type input link of type input. It's a bit more than just the new type, because input link also use the link pop-up field control, and we completely resolved this, so there's no more link field control link pop-up, because it's now migrated to type link options. As you can see, we now have a new top-level option called allowed types. We have an appearance top level, which defines enable browser, browser title, allowed file extensions, allowed options. And as you can already see, we had a switch. We switched from an exclude list to an include list, which is always a good idea, because if somebody introduces a new option and you don't want this option, you have to adjust your configuration. So if you have an include list, you always can define the options you want to use. There's an auto migration introduced, so you don't have to do this manually. Yeah, you have to adjust your TCA as always, but you don't have to do this right away. So there's a TCE migration which runs and says, by time, please update your TCA. And you also see software typo link is not needed anymore, because based on the type link, we know that we need a software typo link. Another TCA type folder, it just replaces type group with internal type folder. There's no more to say. Type group, internal type folder is migrated to type folder. This was too fast. Next type is email. It replaces eval email of type input. We have the same type input, eval trim email is migrated to type email. Trim can be left out. As I said, this is done automatically now by data handler, and we can also leave out software email subst, because this can also be done automatically. Last TCA type is type color. It replaces render type color picker of type input. It also is just the migration from type and render type to the dedicated type. Other things are the same. TCA type, TCA options, it's not dedicated types. They are just new options which replace their eval value counterpart. So we have the nullable option, which is just a Boolean and replaces eval null. The same for required, replaces eval required. There's also a Boolean option. And recently we added option min to core, min or min length. When set, then a min length HTML attribute is added to the field, and yeah, you have exactly like max length, you have to add at least, in this example, 5 characters. There is a bug, not a bug, but we recommend to also set require true, because if you don't enter anything in the field, it's still valid, because you cannot detect this otherwise. The last new option I really like is element browser entry points, because everybody already had a TYPO3 installation where he had Xnews from Georg Ringer, and often you have a dedicated storage folder where these news entries are in, and if you have some group field where you can select those news, you always open the element browser, search the tree, where is the storage folder. So you now can define the entry point. So if you open the element browser, you are in the storage of the news field. This would not make sense if you have a multi-site TYPO3 installation, because it's TCA, it's the same for every domain. So this can also be overwritten per page tsconfig. The next thing is auto configuration and auto registration. Basically, it's TYPO3 often provides the possibility to add custom services to do stuff, or to add functionality like toolbar items, and they are usually registered via the globals config array. And since version 10, we have the Symfony service container in place, which we now more use for this stuff because it's more powerful. Because basically for most of those service services, you don't have to add anything to some config file, because we can auto-register and auto-tag those services, for example, based on an interface. So we can say if service X implements interface Y, we tag the service and then auto-register the service. Benefits are registering during build time, so we don't have to do this on every request. Dependency injection is enabled automatically because we register and configure the services via the service configuration. We can make services, for example, request aware. The configuration module can easily display those services because the services are registered in a registry class, which can be used to get additional information which would not be present in a configuration array. And the services we already moved to this auto configuration and auto registration are element browsers, reports and statuses, backend toolbar items, context menu item providers, link validator, link types. We have 2 more. X-based type converters are migrated, and content objects. The later are not auto-configured, so it's not they are not working directly. The reason is there are some configuration options you have to configure in the services YAML, but I still added them here because it's still simpler than to use the globals array to configure those 2 service types. Next topic is the backend modules. This was a huge step forward because there are multiple things we did to backend modules. First of all, we simplified the registration process of backend modules. We removed TBE modules completely and also the module loader. The main reason for this was, first of all, we don't want to have globals. And the second thing is the modules could be manipulated in the to runtime. So we never had in a state where we can say, okay, this module, for example, positioning is always positioned for this module, because somebody could change this because he could just adjust the array. During build time in the module registry, the new configuration is placed as you know it from, for example, routes in configuration backend modules, PHP. There is another API for accessing the modules. It's called the Module Provider API. I will talk about this later. The modules itself are not just arrays, they are more or less wrapped into objects, so you can call convenience methods again on them. So something like has submodules, so you can check if a module contains a submodule, or has a parent module, so you can check if this has a parent module, stuff like that. This module object is in every backend request included, so you can just get this from the request. And we also added an event for the configuration, which can be used to manipulate the configuration before it gets registered in the service container. Just a short review how the configuration was done beforehand. Something like this. So you had some named parameters, and then you had a configuration array where you always, well, my problem was always I didn't know what exactly which keys are possible. Sometimes sometimes parts of core changed them. So if you have name and ID defined, I was never sure which one was used for the route, what was the route identifier. And the new configuration looks something like that. Yeah, it's still an array with keys, but every key is documented. And you also have, as I said, the module object with the getter and setter, and also the module interface, so you do exactly know which keys are available and what are they for. This is if you want to register an XBase module, it's the same. So that's also a benefit of the new module registration API. So it doesn't matter if it's a normal backend module or an XBase backend module. The only difference is if you have an XBase module, you have to define those two keys additionally, so extension name and the controller action pairs. Yeah, we are not anymore on time, so I will skip. This is just for other keys which were not in the examples. This is one usage of the event. It's used in core from XBase to set a default extension icon if none was defined in the configuration. It's just an example how the before module creation event could be used. Next thing we introduced is aliases. They are really cool because you can change the module identifiers without breaking something, because they provide backwards compatibility. So if you, for example, use URI builder to build an URL to a module, this still works. There's also an upgrade wizard which migrates the user and group permissions, which are stored in the database with the old identifiers. The configuration module displays the aliases, and they also are available for backend routes, so you can also alias routes, not only modules. Yeah, it looks like this. So this is the module configuration with the aliases key. It's an array, and you can define multiple aliases. Next thing is module data API. It's basically for storing user-related module states, so user collapsed or expanded this or this tab. So this can be stored in the module data API, or via the module data API. It's actually still stored in the backend user UC. The main benefit is you can define allowed and get and post parameters in the module configuration, and they are automatically resolved from a middleware. So if somebody uses this parameter, the middleware automatically stores this data for you. The module data object is also available in PSR 7 requests, and you can define it like that. In this example, you define module data, language, and show hidden elements. It's actually an example from the page module. So you say, okay, page module receives or can receive language and show hidden elements parameter, and the value is just a default value. This is how you can access this data in your controller. So you get the module data, as I said, from the request with get attribute module data. Then you can say, okay, allowed values, only foo and bar are allowed values of this parameter or this property, and then you can run clean on the module data object. Yeah, I forget to say that the module data API provides some functionality like get, set, the basics to access the stored data, but also the clean and clean up method. The clean up method cleans all properties based on the allowed values which you add to the method. The last thing about the registration of modules is the third level modules or module functions. Beforehand, you defined them with TB modules ext. We also completely removed this globus variable because it's now just registered the same way as the other modules, so we don't do difference between top level modules, submodules, and third level modules. Third level modules, if somebody doesn't know, are the ones if you're already in a module, for example, info module, and then you have to select in the top where you can say, okay, I want to have the object browser or the analyzer. Yeah, have the same feature set and functionality as main modules, basically because they are registered the same and handled the same. You can also define access permissions now for third level modules, which was not possible beforehand, so you had to enable or disable info module, and then all third level modules were enabled or disabled. So this was like how third level modules were registered, and this is now like how they are registered now, just the same like the main and submodules. Okay, my last topic is backend templates. There we have a simplified module template API. If somebody doesn't know what module template API is, module template API is used for rendering the content frame in the backend. If you go to any module, then you have the content frame, and what's rendered in there is basically usually done by the module template API. So you could also return a response where you say hello world or so, but usually you use the module template API. And yeah, since version 11 there is a factory. You just give the PSR 7 request in the factory method and you get the template, module template object back, which is then used to create the content. And this is now simplified. We have now auto discover of the template paths, and we have auto creating of the response. I will show an example so it's easier to understand. So we create the module template object via the factory. Then we create a view object. We set a template path, assign some sort of content variables. Then we render the view, add this as content to module template. Then we manually create the response and set the body to here module template render content. And this can now easily be simplified. To this, we just create the module template via the factory. This remains the same because we need the request. I come to this in a second, and then we assign the content and just return a return statement is missing here, but render response module template returns a response object. Then. The last thing is template overrides, a really cool thing, thanks to Lolly. Yeah, template overrides do basically override every fluid template in the backend. It's configured via tsconfig. It's based on the composer package name. So if your extension does not use composer.json, this does not work. But I think every extension nowadays uses a composer.json. Yeah, it replaces the TYPOScript X-based way of overwriting backend templates, which basically only worked in two modules. I think the dashboard and the page module used this, and we don't want TYPOScript to configure backend things. We have tsconfig for. But use this with care, because we don't consider the templates in the backend as public API, because otherwise we could never change anything in the backend without anything saying, hey, this variable was there in version 12 or so. So yeah, you can override every template, but use with care, and you have to watch out for the template changes in core. This is the way how you configure it. So you say templates, then you add the composer package name of the package you want to override with an identifier, something like a timestamp. Then you say source package name, so your package, and path. This could be something like this, TYPO3 CMS backend with Unix timestamp, then extension, vendor name, and resources private template overrides. And the same goes also for with user tsconfig. So I don't know if why you would do this, but you could also do this on a per user basis when you add the page in front of it. This is an example how this could be look. TYPO3 sysdex backend resources private template about index. And if you have this configuration from before, and this is your extension, then your about index HTML would override the one from the core. It works for layered partials as well, replace whole file, no merging. So if you have your own file, it replaces the core file. And the definition with the highest index identifier is used, as you know. So if you want to override an extension which already overrides core, you have to use a higher identifier. And based on the backend view factory low level, I don't have the time to explain backend view factory, but also cool. So if you have some time, look into core and watch out for backend view factory. Side effect of this thing is that the package name is available as route option in every request, so you know from which package the current request is coming, or for which package it is located for. Okay, so what's next? Benny already said a few things in the keynote, like webhooks and reactions, and we also surely want to drive the things we already did further, so more PSA14 events, more simplification of TCA, use even more auto configuration. One topic in detail we are working on is TCA type 5, so it will also be a new type which will heavily simplify this whole topic, because it's currently a lot of misuse in the TCA inline type for files. So you may also know the get, I wrote it here, get file field TCA config, which you always copy paste if you want to have a file field. And this will all be simplified with a dedicated type. If anything is missing, or you have an idea for a new API, just go into the Slack channel TYPO3 CMS core dev, present your idea, let's discuss. Or maybe you want to just or already create a Forge issue if you already had something written down, any concept. Then I will say thank you and open for questions.
Thank you. Regarding events, is there a way to order the events? Maybe to, if I want my events to be catch before the other event of the extension or after this one, or all events registered in place in the hook, in the old hook place, are executed just in the registration order.
Yeah, I think they are. I cannot think about some registration order, to be honest. Okay. So you can configure in service configuration. Okay. Okay. So you can do this. And another thing is some events implement some sort of stopping. So if something is reached, for example, you set a specific property in the event, the dispatching is stopped, and your state is used in the calling code. This is also possible. Not in every event, only in the ones it is implemented. Too much information. There's one question, I think.
So thanks for your presentation. I've seen you've done a lot of things with the backend modules. So my question as an extension developer is now, is there a plan to only have modules in the backend without XBase or with XBase, or what's the core way of building more backend modules? What would you suggest for developers in version 12?
I think it, as always, depends on the use case. So I personally always try to just use the core way of backend modules, but there are, so you can basically still use Booth, and I think Booth are fine in the use case, what you face. For example, if you have some kind of custom records and stuff like that, for example news, but your own records, and you want to have some backend module which is similar to the front-end thing, you could just use XBase because you can then use the same repository, for example. So I wouldn't say no, don't use XBase in the backend anymore. Personally, I would always try to not use it in the backend, but it's, from my opinion, still fine, and there are still use cases, and it's still supported.
Hello, good afternoon. This is sadly not the talk about security vulnerabilities, which I would like to have seen. But I was asked to fill this place, and I'm doing my talk, which have been an hour later, making a caching framework work for you and your extensions. Bit about me, if you haven't heard it yet, my name is Frank Berger. I'm head of engineering at Code 711DE, which is a label of the B-Factor GmbH and TYPO3, two agencies from Stuttgart, and Code 711 is basically the shared pool of the engineering resources working for both of those companies. I started as a Unix system administrator who also develops in 1996 at Hewlett-Packard. And I do TYPO3 since like 2005, almost exclusively. So, cache is great. I like cache. Cache made my website faster. It makes everything run smoothly. The editor is happy. The owner is happy because the website comes up fast. Cache is great, right? Cache is great. Yes. Cache sucks. I hate cache. In my earlier days, when I was a developer at the agency, my project manager would always shout, "It's not online," and I had a piece of paper on it which I wrote just had cache written on it, and I just put up the paper. Cache, clear the cache. Cache sucks. It's always in the way. The site is not updated when somebody saves the page or when there are external changes. Cache, that's always in the way. What different types of caches do you know in TYPO3? Any ideas? What cache? Yes? The page cache, yes, the page is cached away. Anything else? As well? Basically everything gets cached in TYPO3. The page tree gets cached, your fluid templates get cached as PHP code, content elements get cached, well, yeah, the configuration gets cached, everything gets cached in TYPO3. What we are talking about is, or what I want to talk about is specifically the page cache and the page content cache, and how to make your extension more flexible to work with that cache. So what can be cached? Basically anything, everything. The question is what should be cached. In our examples, usually we want to cache the output, the thing that is sent to the web through the web server to the browser, and that has to be viewed or wants to be viewed by the user. And there we have to be very particular how we cache it and what we cache it, because as we just mentioned, if I update it and it's not online, a cache needs to be cleared, and that's a manual step. So that's what we're going to do about. Here's a general pattern. This is pseudocode. This is not TYPO3 specific code. How caching is done, basically. The general idea is I have a caching manager which manages my cache, like the content cache or whatever, and I generate a key, a caching key, which has to be unique to this piece of information I want to cache. Then I check if this key has already been cached, if it's in the cache. If yes, I'm going to use that data and just return it. If not, I'm going to create the data here, my time-consuming operation, expensive operation. That's what the page makes slow. Tag it some way, we will get to that, and set the cache, and then I return the data. So next time, if the same page is viewed or the same piece of content logic is viewed, I will have a cache for this unique identifier key, and it will just return the data without my expensive operation. This is the general idea how caching is done in code. I create a key, I check the cache if the key is there. If not, I create the data and return the data. So a bit of terminology. cache key, a unique identifier which considers all necessary context that defines the current state and result. That's important, this current state and result. Tags, related information on which this cache should be purged. We're going to always cache by key and purge by tag. That's where we try to get to. We have a caching front end, this is a caching front end and back end, especially in TYPO3. The caching front end is the mechanism which handles the data, and the caching back end is the mechanism that stores the data. Difference is we basically want to cache, as a developer, we want to be able to just say, I want to cache this. I don't care how it is stored in some cloud or on the file system or in the database. That's something the system administrator or the operator of the website should decide later in production. And that's where this separation between front end, I want to cache something, and the back end, I want to store this cache somewhere, comes together or is separated basically. We are talking about a caching front end here. We want to store some information. What makes a key? That's my idea, what makes a key. That depends on the use case, depends what you want to try to cache. I would put in what is it, the data type, a block entry, a news entry. The plugin maybe, where does it run? I run in list, I run in detail, I run in latest. Maybe the source, where is it read from, if that's important. The target, if it's displayed on the page, column, language, a certain language, why the column or where on the page. Sometimes you have the plugin inserted twice, and it's different, rendered differently. Think about the famous right column content with the latest news and the full list. That's the plugin twice inserted. So we need to differentiate where the plugin is inserted. All these factors need to be considered when I create the caching key. And maybe if you have a login actor who is using the website, is it logged in, logged off? Do I have to differentiate? That's all the stuff you have to decide as a developer, or you have to make it more configurable, basically. So I prepared a little site, a little blog. Here, our blog. Welcome to T3DD22. I can read. I can create a comment. I can go into the backend, a very simple thing, home, archive, detail with the list. And I will create a new blog entry. Welcome to the talk. Nice to be here. And it's great, I hope. Thank you. Oh, that's unfortunate. That's something I should have checked before. I am very, very sorry about that. I checked the code yesterday evening and if the website is running, but I didn't check if everything is there. You have to flash the touch. The effect I wanted to show is probably gone, but anyway. Data draw, incorrect integer value for column virtual. Ah, yes. I need a date. Today, 6, perfect. So, of course, because I cleared the cache just now, no, it's not appearing, I was too late. So where's my new blog entry? I just created a blog entry, it's not there. So what I have to do, I have to clear the cache for the blog entry to show up. And, oh, Leute. I am sorry. Huh? Thank you for telling me that it's not visible. Okay, it's not online because cache, of course, so I clear the cache again. And finally, my piece of content is there. Yes. Sorry about that. I am sorry about that. Okay, nice to be here. And hey, there's a comment section. Great. Frankie says, well, prepare better. Save comment. And there is no comment. Why is there no comment? Can you tell anybody now? Cache. We have problems with cache, obviously. That's why we're in this talk. I clear the cache again, open the page again, and there is a comment now. Okay, so obviously the problem is that our whole plugin is cached in the page cache. There is nothing separated that separates it. So we make it uncached. We will add a simple configuration. Where are we? Xloaderconf. So how to make something uncached, version TYPO3 11. We will add this here again. So when you register a plugin, configure a plugin, there are two arrays. The first array is basically the actions that are there. And the second array is which actions, content actions in the controller should be uncached. So we're going to add that to all of my three plugins. Here as well with detail and save comment. Save it. Clear the all cache because I changed the configuration. We cache everything. And now, Frankie 2. It's better? Yes, of course it's better because it's not cached anymore. So problem solved, we can finish the talk, right? It's not cached anymore. No, of course not, because now all the time the whole thing runs. This is a cheap application, a simple application, of course, and there's not much to do here, but if you think of thousands of accesses and more complicated extensions, this can take some time. This will be time consuming, so we want some kind of cache. So let's add some caching. We start with the detail controller and with the comments. Excuse me for just copy and pasting it. We have the detail action here, where I prepare a new comment if it's needed, and I read from the comment repository. I find the block, find by block, the block entry, and the save comment action where I want to save my comment, basically. So the thing is, the question is, can we create a piece of code so that it will be uncached? So what I'm going to do, I want to cache the whole output of the detail action, comments or no comments. I want just have this whole page here, this whole part, including the comments, I want it cached. So this is the thing I'm going to set up. I'm going to use the parent ID of the plugin. I'm using the PU ID of the plugin. That solves my problem with the position as well if I have that problem. I'm going to take the language ID and I will create a cache key which says block detail, block get UID, the PID of the plugin, the UID of the plugin, the language ID, and that's a pretty good cache key for my use case here. I'm going to get my cache instance, my cache manager instance, and we'll have the cache here, my workshop block cache. One thing first, I have to, before I continue here, I have to configure my cache first. This is done with this kind of thing. I configure my workshop block cache, my cache entity, and I will use a TYPO3 database backend. This can be changed later by the system administrator or by the site operator. But what's important for me, I will have a variable front end. That means I am storing a variable. And I will just add default lifetime of 0. I want it cached as long as possible. Because why change it if it doesn't change? Why? You know. Okay, so I'm going to continue with my detail controller. I got my cache key. And I will check if I have an entry for my cache. I will go here to close the if loop now. And kill detail controller. And now the fun part. This is the fun part. Nope. Okay. I will still assign my variables to my view as before. I will render this view into an array and set this array with my tags. Set this content. Here's the HTML part now, and give the cache key, the HTML content, and my tags I defined for this, and give a lifetime 0 again, and will return an HTML response with the data. For you don't know, this is this part, this render part, and this response part is done for you if you don't return anything from your action controller. So the parent controller, the action controller itself will take care of that part if you don't return anything from your action. But if you return something from your action, it will be assumed that whatever you return is the actual content, or since TYPO 3.11, a response object. Okay, so we will have a separate cache here, and we can run that. Okay, first run, second run. It's a bit fast. Maybe you can see it, maybe not. It is actually a bit faster than if we would render it directly. And this is what so this part is now caching, and if the data is with the cache key is set, you will get the cached part. The tags, as I told before, we cache by key and we purge by tags. We define these tags so the cache, or this piece of cache, can be purged from the cache repository. And I chose to add two tags. The page ID is a tag that will be used by TYPO 3 itself. So for example, if I purge the cache for the page, for my detail page, or all the cache pages, this separate cache will be purged as well. It will be removed as well. If the parent page cache is deleted, that's automatically. And the block ID is, so if I want to remove that piece of block cache entry, I can just say purge by block ID, and that's what we're going to do now, because we still have a problem. Frankie 3 says cache, and of course, yes, it's cache. It's again cached. My content is cached. If I add a comment now, we have the same problem again. We need to clear the cache when it's needed. When a new comment comes in, we have to clear the cache for this block entry. So we have I have a separate part, detail controller. Okay, right? So at that point where I add my comment to the repository, that's here my save comment action with the comment coming, that's from the form data. I add a new date, I add it to the comment repository, and then I redirect to the detail page. Simple. So I know now here a new comment has been added. At this point, I want to get rid of my cache for this block entry. So what I will do, I will get my cache manager again for the same cache I created before. And here I flush by tag, block ID, comment, get block, get UID. The block entry is relation in the comment, get UID. And with that, all entries, all cache entries tagged with block ID 15 or 4 will be purged. Whatever they are, for whatever reason I created them, they will all be purged at that moment. That's why we're gonna flush by tag, so we can get rid of all of them that are tagged with this tag. Like Benny said 2 days ago, you can even do from the backend in some cases, and that you can define tags. So let's try this. Frank4, test again, and Frank4 tested, and Frank3 of course is there as well because we just created that. And the cache has been recreated at the same moment. So because of the reload, it loaded the block entry, and the cache has been created at the same time again. So I don't have to worry about that part anymore. So let's take care of the lists. I have, no. What makes a key? Again, what makes a key? Some side note here again. One problem with the key is actually, you have to take into consideration as well what the fluid template is doing here. So if you have a if or case or something else in the fluid template where a decision is made to render the one thing or the other thing, that needs to go into the key as well. So you have to be aware of that. A good pattern for this is that you, for example, externalize this in the domain model. That if you have decisions that you can ask your model, your block model, if it's left or right, and then you can ask the model here as well, will it be left or right, whatever needs to be decided. But that's a pitfall you have to be aware of when you do the fluid parts of your extension. That any decision that's in there needs to be in a cache key as well. Otherwise, you will get what we call a cache poisoning. You poison your cache with wrong content, basically with wrong decisions, or with inconsistent decisions. Let's take care of the list. Let's do the latest controller and the list controller. I don't know if you saw it, but we have classic latest controller here. And with /archive, I have a list controller with paging. So let's do those. They are less okay. So we have the latest controller, which has an index action, which reads all my recent 3 block entries. And I will add caching here now. It's uncached right now because I configured it that way. Latest controller. Same procedure as with the detail controller. I get my PID, I get my UID, I create a cache key, block latest. If I'm in the latest controller, I could of course try to add the class or something like that as well, if you want to be a bit more abstract than I was here. And the lower part, you see the schema, you see the pattern, it's always the same. Bit formatting, okay. I test my cache key. If I don't have data, I will create my data set and render the HTML output. I will give you a block latest view as the tag key, and I will give again the page ID. It's good practice. So you can really purge all cache with just purging the cache tree. And we'll add the cache key again, data tags lifetime 0, it won't time out. And then I return the data, or better, I will return the HTML response. Right. The same with the list controller. I will take my upper part. I will take my upper part again. Same here, it's an index action. I will find all my block entries. I will have the page here because I have paging, the whole handling of the page part. And I will add my lower part, list controller, do the words. Okay, what's happening here? I'm taking the current page, so I have to do my page stuff first, of course. Now I will zoom current page 1, that's what I do. Current page, let me check, paginator, items to page, current page. I will get I get from the widget, I get my current page, try to figure out which page I'm on, and will cache it with the current page. We can discuss if it's a good idea or not, or if we need it or not. There are some pitfalls with that. But anyway, I will have a block list view tag, and I will use the page ID again as tag. Same procedure as before. I render the data, I cache the data, and I return the HTML response. And once I'm there, this part is cached as well. It's pretty fast though, but it is cached, I promise you. Okay. Good to know. Tag page ID $PID will be purged when the cache clear for the page which this PID is called. So that means in the backend, either if I press this icon or if I clear all the cache. That cache, the block cache, will be cleared as well, because all page IDs will then be purged. And XSpace controller can return the content. If it does not return the content, this render will be called. So basically, normally the XSpace controller will do that for you. If you want to use caching or if you want to implement your own cache, you have to do it manually and return the content. Now, I have editors which are doing changes in the backend. Yeah, we are optimized. My programmer said we are optimized now. That must be worth something, right? So, another entry, and we will make it visible, and we will add a date, a different date, just for meshes. Another teaser, and another lorem ipsum vitae. I heard there is a tool for that. Okay, save. And we reload. My programmer made something wrong. My content is not coming up, and it's all optimized with cache. Right, no. We want to do, of course, dynamic purging from the backend as well. There are page.ts configurations available, yes, but I don't want to burden the integrator for understanding my plugin, so I will do that inside my plugin. Once the content is saved in the backend, I will flush that part. For that, I will add a data map hook, which hooks into the data mapper, which is the process that runs once a content is stored in the backend. I will just copy that part here, copy, paste, Yes. Cancel. Okay, and I will register it. By adding these lines to the table. There are two processes that run. It is once the data map class, the data map process. This is when you save something in the backend. And the command map is if you move something around, like copy, paste, moving, stuff like that. There are two different parts, but you can handle it in one class, basically. And once this is called, this data map class, and let me double check that we have the right workshop.data. Yeah, that's correct. I will get the cache manager when it's initialized the class, and I will check if for the process in the process command map if something is deleted or moved. And in the process data map, after database operations, I will do clear my cache for table ID status. You will always get the table and the ID, and you will have to check if we are talking about our tables, my domain model block table or my domain model comment table. Otherwise, you will purge the cache for TD content or for TX news or whatever. So you have to check for that whatever is coming here in the table variable, that it is actually talking about you, the whole process. Okay, and if I save in the backend domain model block entry, I will instruct the cache manager to flush by tags. I will flush the tag for this block entry, and I will just flush everything from the latest view and the list view. Why? Because I might change the teaser, and that would need to be updated in the list view or in the latest view. So I have to flush it, and I don't want to start to calculate in which part of my list archive page this block entry is stored. That would probably be too much overhead, or it's dependent on configuration. So I decide right now that I will just flush everything that has a block latest view and a block list view tag. And the same is when I move or delete a comment, I will flush by tag block ID with the block ID for that comment, so the block entry with the comment will be removed from the cache. Okay, let's try this. So go here. I have to clear the cache, so, well, can't have everything. I will start to create some caches so we can see the effect. Okay, now it's cached again. But now if I, for example, change this another entry, yes, another teaser, yes. If I change now and I save it, it will be updated immediately here and of course here. And if I moderate this guy here with his stupid comments, this Frankie 4 guy, no, he won't comment again, and it's gone. So now we have automatic cache management inside our own extension. It's not that much to do, or not that hard to do. So basically, you can start doing that with your extension as well, and you can get creative. You can start caching simple parts, single parts. Another advantage is I could now add cache headers because I know how old the cache is or how long it will be valid for the HTML headers, if you have a caching front end in front of it. And, well, that's it. Questions, discussions? Somewhere? The gentleman?
Yeah. What to do if a new request comes in while the first rendering process is running. So
that's a good question. It will probably override the cache at that point. I rephrase the question, if there are two simultaneous requests coming in for like the detail page, and while the cache is not stored, it will basically do it twice. There is no raised condition here. So that's a caveat we have to live with. It was actually Helmut Hummel tried to rework the caching system inside of TYPO3 to have something like the login mechanism available, but it never emerged, sadly. Maybe in the future we will have a better caching system here. Anybody else? Okay, well, thank you for so far. I will put up this talk on our website on code 711D. There is a GitHub repository for this talk where you can download the whole workshop, basically, the whole blog extension, and you can go through, let me show you, appearance, exit. You can use the branches here to go through all of these steps, so you don't have to do the copy-pasting I did just now, but you can go through the steps and just check out the different steps. It will be linked there as well. And so you can try it out and play around with it. It's open, you can use it, take the ideas as you like. Thank you.